we will have an introduction session, right? So in the introduction session, you will have to say what's your name, what's your experience, what are you doing right now, and any of your hobby. You can add one hobby, right? Any hobbies, right? So that we will do. And second one is, by the end of this course, on the 4th day or 5th day, before that, one of you, all of you, one by one, you should speak with me for 2 minutes, wherever you get time, right? That time I will, if you have any questions, you can ask what you are doing, what is your plan, what you expect. If you have any question, I can answer, I will help you. That way we can network, right? If you have any future plans in abroad or networking here, any studies, working in private firms, working in teaching abroad, all that, whatever questions, there is no question like a dumb question. So all questions are fair, right? So you should utilize that time to have a kind of an interaction. If you have any of your particular experience, that also you can share. Okay, we'll see. Yesterday we were talking about the local limits. I explained that the whole system has 3 layers. One is the federal, where the Environmental Protection Agency, then the state regulation, and the third one is the local. The cities and towns, they can have their own limits, own conditions, so that they can impose on any dischargers, right? But those limits must be more stringent than the state and federal. They cannot be more lenient. So that is what is one of the requirement. And all these local limits must be technically based. Technically based in the sense, what is the capacity of the treatment plant, and what hydraulic loading, what organic loading it can take, what is the capacity of the treatment. That is all included in the technical base. So you will assess how much flow is coming into the system and how it is treated, what kind of treatment system exists. That all is the basis for generating the limits for limits at local. Okay, then site specific developed for each POTW, in the sense that is the treatment plant. If you have each treatment plant is different. You cannot use the same limits when you are developing from other treatment plants, because each treatment plant system, capacity, everything is different. Then developed for each pollutant of concern must be enforceable. Local limit development guidance, there is also a guidance how we should develop. So what is that? Developed for each pollutant of concern. If we see the overall treatment, in some places there are a pollutant of concern, right? It depends. Some areas they may be having a PCB, there is a pollutant in that area exists. Then you can have an additional limits when you are authorizing the discharger to discharge to the treatment plants. Then what is the procedure of the treatment plant? Pre-treatment program must have identify, locate the possible industrial users. It also depends upon the what kind of industry exists in certain area. Certain area there may be a food processing industry. In certain area it is dominated by the categorical industries like a metal industries or metal finishers. In certain area there are industries where winery industries may be there. So accordingly you will have to design the treatment plant. There are two kind of system. One is, I have a cities where we have delegated, they have a municipal treatment water system, and also if there are more industries, then you cannot discharge all the industrial wastewater to the domestic one. It has a capacity, As yesterday I was telling you, it may be 10%, 15%, or depending upon the capacity. You have to do a technical assessment. That is why I was mentioning about an engineer or professional engineer will design and make sure that your treatment plant is in a good condition with that. So that is why if the industries are more, what he will do? They have a separately designed industrial wastewater treatment plant. I have places, they have a domestic wastewater treatment plant where all the residential wastewater is treated, and they can add, depending upon the number of industries, which it can take the load hydraulically and organically. And if the number of industries are more, they can also have a separate industrial wastewater treatment. Yesterday, that is what you were looking at. That is a common effluent treatment plant, correct? So different industries, they discharge it to certain places. They have an equalization tank. Then they regulate the flow, and industrial, then the industrial water is treated, make it safe, and discharged accordingly. It depends upon the type of the discharging location where you are discharging, whether you are doing a land application or you are discharging it to the sewer, the rivers or streams. So it depends upon that. That is what yesterday we were looking at, the common effluent treatment plant, because you cannot tell the individual discharger to have their own treatment plants. That is why they combine and they integrated. They have an integrated system to collect all the wastewater. They mix it at the equalization tank, because this is it serves two purposes. One is you can regulate the flow, because some of the industries may be discharging intermittently, not regularly, not continuous. It may be possible they may be 1 week they have a process operation, they discharge more, and other time they discharge less. So you cannot just keep on discharging when the treatment plant is the process plant is in operation, and you cannot keep it empty when there is no discharge. So that is why the equalization tank is built. It can regulate the flow, and also the mixing of wastewater takes place there. Suppose an industry producing a low pH wastewater, and there is another industry which produces a higher pH wastewater. So they can neutralize there. So that avoids the treatment, right? So that is how this is. These treatment plants are designed. So that is the industrial wastewater treatment plants, right? So identify the characteristics and volume of the pollutant contributed to the wastewater treatment plant by industrial users, and notify the industrial user for applicable pre-treatment standards. Each industry, you will give the limits depending upon the type of industry, what type of wastewater coming out of the facility. Accordingly, you will provide a limits, right? For example, if it is a food processing industry, your focus is more on its BOD removal at the pre-treatment site, and also removal of suspended solids. That is how it is designed. Receive and analyze the report submitted by the industrial user. So all these industries, they are regulated. What they are discharging, what volume they are discharging, whether they are following the regulations or not. Here also it is the same way. The pollution control board or any authority, they have to make sure that these things are monitored very well. So what procedure must be a POTW pre-treatment program? Conduct a random sampling, surveillance and inspection event. Conduct slug discharge evaluation. Investigate instances of non-compliance. Comply with the public participation requirements. What it means? Conduct a random sampling in the sense, if there are certain situations where if you are going for an inspection on a regular day, it may be scheduled or unscheduled. If you have a suspicion, there is the data which are given by the industrial users are little confusing. then you can have a random sample. You can go at any time and sample them. Then you can compare, see whether really they are doing the job. That is kind of the next step that will lead to the enforcement or the warning, or what steps should be taken for that industries. That is all evaluated. Conduct a sludge discharge evaluation. Sludge discharge in the sense, I think yesterday Deepak uploaded a glossary document. You might have gone through that. Don't just leave in the system. I want that you should print or read that, understand. So those are the terms. Sludge discharge evaluation in the sense, a big hydraulic load is coming into the system. That is what I gave an example yesterday. Sometimes what happens, the discharge is 1,000 gallons per day, and sometimes 10,000 gallons per day. You cannot do that. Any discharger cannot do that. So they should have an equalization tank and regulations. If the slug occurs, then they must have a communication with the receiving end to make sure that it is handled properly. Right? So investigate the instances of non-compliance. So always you will tabulate how many times they do violations. Right? So you can't expect any system built 100% correct. We know all the industry, there are so many changes. There may be upset, there may be a power loss, or there may be wrong sampling. Many things happens. But if they are happening once or twice, then if you are okay with the kind of explanation they give, if you feel it is a genuine, then you can allow them and make sure that those things never occur in the next time. Right? Comply with the public participation is an important component. Wherever the industries are there, it is kind of a requirement to make sure that the public in that place must know what is going on. They have the right to know what kind of activities are going on, whether it is taken care of or not. Right? They have the right to know. So industrial wastewater survey, identify and locate industrial users subject to pre-treatment program requirement, pre-treatment series, industrial users and survey procedure. That is what I mentioned a little bit yesterday. You will have to do a survey what kind of industries are there, whether they required a permit or not, whether they required an authorization or not. If they are producing the wastewater which is similar to the domestic wastewater, then it can be considered they can discharge. They may not need an authorization from you guys. So that is the person in authority, the controlling authority have to make a decision. If it is delegated, if it is directly issued by the government or the board or any authority which controls, which implement all the environmental regulations in that location, then they can make a determination whether they really need or they do not. Right? So there are control mechanisms. What it says that the control through permits, orders, similar means, the contribution from each industrial user to ensure compliance with applicable pre-treatment standards and requirements can be achieved through individual or at a general permit. What is the general? There are many industries which produce a very small quantity of wastewater. They say that we produce that intermittently, once in a week, once in 2 weeks. So in that case, they have a storage tank at the place, and then they can, when it is filled, then it is taken to the nearest treatment plant and then. So that determination has to be made. Those are the control mechanisms, how these individual industry, depending upon the type of industry, small or a medium or a bigger one, that the determination has to be made by the controlling authority. Then who to permit? That is, the determination has to be made. I talked a little bit about the significant industrial user, in the sense who are having a 25,000 gallons per day of discharge continuously. In that case, you have the actions, and you should need a monitoring, proper monitoring. They will make a big impact on the treatment plants, right? So, and a categorical industry, that's I explained already, where even the volume is low, and they can make a lot of impact on the treatment plant as far as the interference is concerned, and also the pass-through is concerned, because they may contain a toxic substances. That is why you will have to make sure, irrespective of the volume, however it is, it may be 1,000 gallons, 500 gallons, like that. So optional permits, non-significant industrial user, non-significant categorical user, waste haulers, and ground remediation sites. In the sense, there are situations, they are non-significant industrial user, in the sense they produce a very small quantity. You cannot put a more regulations on them, right? That determination you will have to make. If they are following, if they are collecting their wastewater, but you have the right to go and see whether really they are doing the stuff or not. So in those cases, you can collect, they should be able to collect the wastewater, store it in their place. It depends type of the wastewater they produce. If it is hazardous, then there are different regulation, how many days they can store on the system, how they are storing, whether they have a secondary containment, whether they are storing in a proper containment. There should not be any leakage. A lot of workers will be working in that area. You should make sure that you should work for their safety, whether they are the each worker working in the process plant is having a proper protective equipments. So all those things have to be seen in case of a categorical industry. And here is the picture. You see, some people, they will just stop the truck and drain the wastewater in the manholes, right? So that is why what they do is they will try to find out, they will keep a camera there, they will see who is doing this, right? They follow. So you should, that kind of an attention is paid to this kind of system, right? And who gives this authorization? Pre-treatment permit, I have already mentioned EPA, and the reasons in the sense, the state has an four, maybe having a 4 reasons, 5 reasons, 2 reasons, depending upon the size. So there is kind of an understanding there. It is exists everywhere, how our MLA, MP areas are decided. Similarly, the reasons are decided here, how they do that. So NPDES approved state permits, in the sense, if they are discharging it to the rivers. Rivers are to be protected at any cost. No one has a right to destroy the very ecosystem, because it is interconnected. People drinking water, a lot of fish will be affected, and the whole ecosystem is spoiled if the water quality is destroyed. It also enters the food chain if there is a contaminant in the water. So that is why you can understand the gravity of importance, how much the people involved in the system should be careful. That is why I was more emphasizing on the responsibility, how much responsibility lies. They cannot just take it lightly, because it has a multiple effect on the total system, right? So then that is the controlling authority, in the sense, whoever may be, who is monitoring, that is the indication. And these are the industrial users, significant industrial users, they also need an authorization to discharge. And compliance monitoring, how we will monitor, can be announced, unannounced, suddenly you can go and see the sampling, and also can be conducted independently or in conjunction with the compliance inspections used to satisfy the federal requirement. Then sample must be taken with the sufficient care to provide a defensible data. In the sense, your data which is collected, you should make sure that it is a representative data, right? it should represent, the measurement is very important in the system. If no measurement, no pollution. That is what happens in the many cases. So that is why your data should be defensible, because big industries, if you take a sample wrongly, they may go to jurisdiction, they may go to court. You should be able to defend when you are taken, because other side also the competent people will be there. In fact, there will be much competent people will be on other side, right? So you should be strong enough, technically sound, to understand its implications, what you are doing, whether you are doing it right or wrong, right? Make sure that, that is why your learning should be always open. How you do the things, you should do it independently, understand the consequences when you do any work in the system, right? So that is what it mentions. And compliance monitoring, there are series of documents how you can do the compliance. When you say the enforcement, you cannot just do the enforcement, right? You should have a proper documents to thinking that it may go to the higher level, it may go to the great extent. You should be able to defend the data what you have collected, the procedure what you have followed. That is why you might have heard about the standard methods are there, and different people who are having the chemistry background and environmental background, they will be knowing what are the standards, what are the methods you will have to follow. That is why there are many guidance documents available at a federal, state level, how you can do the analysis. That is why one of the requirement is you should have an analysis done at an accredited lab, not the random one. There are accredited lab in the sense they have a reputation, they have a standards, regulations, what to do, how to handle sample. They are well trained. This is the third party. There are many industries where they have their own staff who can do everything, but they should be certified and trained. So that is what it says, right? That is what I just mentioned, one picture there where surveillance is required. If you find any suspicious activities, there are many ways how you can handle those things, right? So there are different ways, different middle tier and a significant industrial user, minor industrial user, that there are number of categories exist. You can divide them accordingly and give the privilege, how they can discharge, how they can handle the wastewater produced by the facility independently, right? Then the enforcement, that is always there. If they are not following the regulations, then the ultimate is warning and make them understand, then the penalty. Then the enforcement response plan is important. It gives the steps, what are the steps you should follow if you want to go for an enforcement, because you should understand that it may end up in the court, it may end up in the judiciary. Then you should be able to defend your data, what procedure you have given a sufficient time to the industrial users, what they have done, how you have educated them, whether you have informed them, you have warned them. Systematically it has to be done in order to take any action, right? Then the funding and personal equipment is always important. I always believe that people who are working in the system, they must have protective equipments, and if they are working in the measurement system, then they must have proper equipment and proper training. Those things are very important. Things change. If the people who are giving you the data is not just the number, it is a language of the treatment plant. It says this data means you can predict what is happening, what is the health of the wastewater treatment system. That is how you can predict and understand, and accordingly the action can be taken, right? Record keeping is also important. You will have to keep the proper record for many years. If it is challenged, then he should be able to show it to the required authorities that these things have really happened, and also the records are maintained. There is a proper management system. Some of the records are maintained for 3 years, 5 years, it depending upon that. Then when you are accepting the wastewater from the industrial user, you should make clear for how many years these data are going to be in our system, right? Some data, if there is a litigation, you have to keep it forever until the litigation is over. Some cities decide 3 years, 5 years, 10 years, and some data has to be forever until everything is done, right? And public participation, I have talked about that. You have to involve the public. Public has the right to know what is going on in the system, right? And the annual reporting system, every industrial user, if it is a delegated city, has to submit a detailed report, what is happening, what is the total discharge, how they are taken care of, and what are the consequences if there are any upsets in the system, how they dealt, what action they did. That is all the record, and you should have in a system. Once any violation occurs, then how it triggers different system, how we will follow, because today one person may be knowing, but he may work for a few years and go away. Then the other person who is coming into the job, he must know what procedure should be followed, right? The proper training and the documentation is required here. So industrial user responsibilities, I have mentioned what are the issues with the potential slug loading and sampling and the changed discharges. It happens. Some people do go for an expansion, then you will have to revise the limits and you will have to revise the procedure, how that has to be managed. Every industry wants to expand. The old stuff doesn't continue. Then that has to be modified accordingly. And notification of bypass is important. Sometimes, in the industry, what happens, large wastewater is produced, our treatment plant is upset, then you give and authorize them to bypass. But anyway, it is not going directly to the rivers. That will make a problem. If they are discharging it to the another treatment plant with the pre-treatment, then you will give a little bypass notification the industrial user must give, so that they can be prepared, understand how that the wastewater which is coming out suddenly has to be taken care of, right? Oh, right. So I have already talked much about the categorical industrial users reporting requirement, because they are consist of and maybe a toxic substance. So we must be more careful about those kind of wastewater coming into the system, right? This is the same periodic reports, 90 days compliance report. You can specify, you can give if any big expansion is going on, you can always specify you have to submit the report in 3 months or 6 months, like that. Then other significant industrial user reporting, periodic compliance report, slug discharge control plan, all should be in place. If suddenly any discharge happens, then they should have a plan in the industry itself. If there is a sudden upset, if there is a sudden spill, how they will take care. So that is why that plan has to be approved, right? You see, in this situation, what he will do, what actions he will do, step-by-step procedures have to be there, because people may be working in the night. It is not a one-person job. People will turn around. So every person should know their job. That is why I was specifically telling that people who are working, they must know their job, and they must do their responsibility, discharge their responsibility very well. So that is the very intent of this reporting system. All SRs are required to conduct a self-monitoring system. So they should assess themselves whether they are doing it right, whether they need any changes. That is shows they have to conduct, that is the self-evaluation. Then there is also the procedure where the signatory and certification requirement, baseline monitoring report, 90 days compliance report. So why I'm telling is you can understand the regulation side. After this lecture, you are going to see how you are going to treat the wastewater. First, you should have a system. Once it fails, what you will do? How we will bring all these industrial users or a discharger into one common system, right? So that is what we are talking about. Then industrial users record keeping. So that the record keeping is also done on the industrial side, industrial user side, and also on the regulator side. This is the National Pretreatment Program Manual, which is given in detail how the regulation is three-layer regulation takes place at the federal and the state level and the local levels. Major changes have occurred time to time. I have told sometimes people won't be knowing, right? So that time we should go step forward and modify the system existing. Then there are given the industrial pretreatment program, responsibility, and the different dischargers, what are their responsibilities, what they should follow. All can be, step-by-step procedure has to be done before discharging, right? Domestic wastewater facility discharge, these are the standards I just mentioned in briefly. It may change from place to place depending upon the type of industries existing and type of the town. I mean, whether it is a small one or a big one, they have any issues really with the cities, towns, treatment systems. So 30 milligram per liter, 5 days BOD, suspended solids, fecal coliform, and the pH. These are some of the standards, and also some of the pollutant of concern. If they are there, then you need any additional requirements for that. And number of, we will deal these things in the next lectures, where what are the different kind of biological treatment and how the stabilization plant, trickling filter, wastewater treatment plant, combined sewer, case by case basis, and treatment plant receiving minimum concentrated influent wastewater. We will see how they are dealt in our the next lectures, where we learn about more about the treatment side. Then pollution effects on the soils and crop. I have already explained about that. All the three components, water, air, and the lands, are affected. Number of pollutants. There is a climate change, water pollution, microplastic, and pesticides what you use for the plants. That all changes the very fundamentals of the ecosystem, right? And protection of soils and crops, because I said whatever the contaminant is discharged to the system, if they are not taken care properly, not treated well, it will enter the food chain through the crops, right? Fertilizers also, people use a lot of fertilizers everywhere now. It is a fashion now. Organic has come back again, and that has become a fashion also now. So these fertilizers, they use about 40 to 50%, 50 to 60%, and rest will just drain off. They are one of the major contributors for our nutrient removals. Right? I think we came to the end of this lecture number 2. And if you have any question, we can always talk about this. I have took a little more time to make you understand how this overall the regulatory system works. There should be someone to control, oversee, right? That is what it highlights. You have seen the different layers, what are the manuals, what are the type of industry, how they are taken care of, and various components in the treatment systems, and how the regulation is applied to the treatment system and the people, industrial users, and how the participations of the people also plays an important role in the overall systems, right? I think, thank you. If you have any question, we can talk again. Yes, go ahead.
After treatment of the industrial wastewater, so there are some are transferred to the rivers, and there are some industries which are near seas, so they transfer it to the marine water. So the system is different for the transfer in rivers and for the sea, or the same? Is there any difference? Because seawater is different from fresh water, their salinity, the TDS, everything is different, so the requirement is there different.
Good question. But you cannot discharge to the sea just like that. It has to be, see the quality of wastewater you are discharged. You need an, whether you have to discharge to the sea, how you are going to discharge. It all comes to the surface at the shore. You cannot just discharge. Earlier, maybe, I have seen some people have done that, but now the regulation doesn't allow that. Without treatment, you cannot discharge to sea at all.
So that's what I'm asking. The treatment, the procedure of the treatment of the systems, are there any another equipment used for the treatment? The system is it same for the fresh water and the marine water, which are used by industries?
There is no regulation where you can just discharge it to marine waters.
That's I'm asking for the treatment. There are equipment, there is a process. So the process is it same for the fresh water and for the marine waters?
No, marine water process is different because it has already a high salt contents, and we have dealt with that many times, where the seawater is used for the air conditions and all before, but nowadays nobody use. You will have to scrap the entire system within 4 to 5 years. They never use it. Right?
Thank you, sir.
Good morning, sir. I have one question.
Okay, we'll put the third one. Right?
Sir, can we use wastewater in energy generation or fuel, etc.?
You can use, we generate, we will study in these lectures. If the wastewater, we treat them anaerobically, and the methane is generated, that can be used it for the energy purpose.
One another question cases. Also, sir. In rainy season, how to maintain the wastewater treatment plant in rainy season?
Yes, that is true. But you have to consider that dilution, right? You cannot cover that whole system. You will also account for the volume of the water entering into the system. And if you go to the cold countries, they cover that because of the temperatures, right? So, but here they are open system. Yesterday you have seen that if they are a clarifier and other stuff there, there will be always the addition of that water. It makes a dilution. It doesn't harm that way.
Right? Okay, sir. Thank you, sir.
So yesterday we saw the processing plant which treats the water. So as you told us, it was open. The area was open. So there I see many breeding ground for mosquito and insects.
Always.
So
that's why they are more resistant for mosquitoes and others.
Yes. So and there would be many microorganisms also in that water.
Yes.
So if we use that water for plantation, for agriculture, so the microorganism from the water will affect the plants. No, they will affect their growth.
No, they are not that kind of a microorganisms. I will tell you in this lecture how much they are useful, those microorganisms. They will not affect any plant or any.
Even fungus present there, no, it
No.
will not.
We use fungal bacteria for the treatment. People may be knowing many people.
Thank you.
We'll see that those
Okay.
kind of treatments.
Thank you.
Right?
Good morning, sir. Sir, I have a question.
Okay.
Sir, as we are studying that there are so many rules that government is imposing on the industries, and industries are also claiming that they are discharging under the standard limits. But we are seeing that still there is so much pollution and eutrophication in the rivers. What are the possible reasons for this?
How much percent of wastewater is treated here?
Like
Very
it
less.
depends on the industry.
Very less. There are some industries.
Yes.
Many industries are just they are not taking care of. That is the responsibility of the regulator or the
Yes.
people who are involved in that system to make sure that they are really doing the job. That's what I said. The number is has to be. It should be supported. It should be a representative. Whether that really number is right, that is the responsibility of the people who are monitoring that. They should do their job correctly. If it is wrong, then they can take always an action. So if you are tomorrow, if you become an manager for a treatment plant, it is your responsibility whether those things are right or not. If you are on this side, then it is responsibility whether they are doing it right, because at one situation I was on both sides, right? So it is both sides. You should know what are the consequences and whether they are doing the right things, what is wrong going on. You should be able to
We can say that there are still the loopholes in the discharge.
that loophole has to be fixed by them only, right?
Good morning, sir. Okay, so you have given this regulatory, it's based on US, right? Okay, so my question is, how can India achieve such kind of like a state like US in terms of this wastewater treatment?
Correct. So that was the very intent of this program. Just this is the model. Similar models are here also, right? So only they have to be implemented properly. People like you, tomorrow you go and see where are the issues in the system. You educate the people, bring the more regulations, more stringent regulations, make sure that somebody has to do it, right? So that is the very intent. People who are there in the system, they should do that first. Then slowly they can modify. You have to keep the step forward to make sure that the system works. Who will do? Public participation, and the resources have to be provided. Make sure that things are working properly, right? It is the responsibility of everyone. Okay. We'll go to the third one. Lecture number 3. Number 3. Okay, good. Okay. Now, right. So this lecture number 3 specifically for the small and medium industry. At one point I mentioned that if a big industry is there, if has a lot of resources, they can have their own treatment plants. If there are small industries, right, medium industries, they don't have that much resources to build a treatment plant. They need a system. They have to piggyback on some system which is existing. That is what you saw yesterday, common treatment plant like that. That is what we were telling, that the dischargers will discharge the wastewater to the city treatment plant if it is having, even the domestic treatment plant has a capability to take some load. And also many cities have their own industrial wastewater treatment plant where all the wastewater from the industry is collected and treated. We will see those things, both the examples in one of the tutorial, right? So you have seen the common effluent treatment plant where the small industries, they were collecting their wastewater, discharging it to the common treatment plant in an equalization tank, then taken care. It is possible because they are in the industrial area. Suppose the one industry is somewhere in the corner, what you will do? So there are certain issues. It is not that the regulator will implement the regulation anywhere, but at the same time you have to see the issues on the industry side also, right? So that is what this particular presentation highlights: small and medium industrial waste management issues. What are the issues? Issues of small, medium industrial waste management: general discharge prohibition, interference and pass-through, we talked about that. These, however small it is, whether it is a small industrial unit or a medium, they should make sure that what they discharge should not cause any interference or pass-through, right? How they will discharge? Municipal system, a city town has a sewer system built all over the service area. So industry which is close to the sewer system, they can have their own pipeline and then discharge it to the sewer system. That is how it enters the city treatment plant, correct? So what you will do, if there is industries in the sewer system, then you have to give an authorization what kind of industry it is, how they are managing their wastewater, right? How you will regulate whether it is in the service area, who will take care of that. So if they are constructing an industry where they don't have a place to discharge, then city also has a responsibility to educate them or make a provision to accept the wastewater. Of course, it is not there, if they are causing any issues of pass-through or interference, they can deny. But if industry is coming to the term, it has got an advantage also, right? You should not be in a, you are also making the provision for industries to come to your place. They will generate a lot of revenue. They will give a lot of employment. The whole economy will change. So at the same time, both sides you will have to know. They also have an issues, and how that has to be dealt by the regulation or the cities. That is also an important aspect. So one thing is sure, but they should not cause any interference and pass through. Many industries are there. They want to work with regulations, cities, and make sure that they treat their wastewater well. There are many industries, but only they need a proper understanding between them and the public. There are three components. One is the regulation, another is the discharger, that is the industry, and third the public also. Public also you should involve. What is going on, what kind of industry is there, is it causing a problem? It is the responsibility of all. Then what happens? Small industry, they don't have any engineers. They don't have a full-fledged staff. So then they hire a consultant, make sure that the proper report is prepared and where they will mention how they will take care of. Then it comes to the regulation and he will approve and he will say that under these conditions, these are the requirements, then you can discharge. So they also have an issues. So, but the responsibility of the regulator is to make sure that it will not cause pass-through interference. It is on the both sides, even on the regulator and discharger side. So pre-treatment basics: See what happens, even if they are producing a very small quantity of wastewater, if it is a highly corrosive, if it is a very low pH, then you should make sure that it will not spoil the entire sewer system. The city has a right to protect its sewer system and also the treatment plant, right? So those are the important things in their discharge restriction and prohibition of dangerous waste regulation. You have seen, I have shown some pictures yesterday, what will be the consequences if they are not taking care of the wastewater, which is toxic in nature, which is contaminated, which is causing an issues with a very sewer system, right? So if it is a corrosive, you should make sure that the wastewater what they discharge is between 5 to 10, which is safer for the concrete sewer lines or any kind of a sewer system. So what they will do, if they are producing a very low pH, then you will tell them you have to have an equalization tank, make sure that your pH is in this range, and then you can discharge. That is a pre-treatment system. If they are discharging with the high solids, then you will say you have to have a settling tank, then rest we will take care of that. You remove certain, if it is a highly, see city says if it is a 500 or 300 we can accept the wastewater, if it is a BOD we can accept, then if it is a extra then they have to remove, right? So that is how the system works. Then non-contact cooling water significant volumes, that is another issue today. Everybody wants air condition, right? Depends upon the climatic conditions, situations. But this produces a lot of wastewater, which is has a different water characteristics. You should make sure that that is discharged to the sewer system properly. If it is a big industry, you can and close to the treatment plants, they can have a direct line, right? They can have a direct line and then discharge at the headworks, right? So your sewer system also has a capacity. You cannot ask a big industry to discharge into the sewer system. Small industry, if it is not affecting the very system of the sewer system, then you can allow, right? Non-contact cooling water in significant volumes, and storm water and other direct inflows. Storm water, if somebody was asking the rain falling on the clarifier is different volume than the entire area. You might have seen the storm water, if it comes, what happens to the whole system is destroyed. If you don't have a proper storm water drainage, if you have not taken that into consideration in the design of the sewer system, all the sewage will just come everywhere, right? That will, waterborne diseases, 80% of the diseases are waterborne. So that is why it is important when you are planning, make sure that it is done for a 30 years plan and every component of the design factors are considered. Wastewater significantly affect the system hydraulic loading, which do not require treatment. The hydraulic system is also important. Volume also can affect the very treatment system, right? Not only the loading, organic loading, right? And fats, oil and grease control approach. I mentioned a little bit about this yesterday. All the restaurants, all the gas and car washers, and there are certain industries which produces oil and grease. That has to be taken care. That is the very first treatment after your grit system. We'll come to the biological system later. So if the oil and grease is not removed at the very first stage, it reduces the overall efficiency of the system. So estimates fog causes just over 50% of all sanitary sewer overload. What happens? It blocks the sewer system. If the sewer system is blocked, what happens? Overflow. Sewage is everywhere. Then it also affects the health of the people, right? That happens in the storm seasons, in the rainy seasons. if you don't have a proper drainage system in the place. So you can understand the consequences and the depth of the issues. This all needs a resource, and it may be in terms of a funding and also the people. You need a big department to handle in each small places, right? So that is how the very intent that the people should, develop the system depending upon the town or cities and the volume of wastewater is produced in that particular place. So those things are important. Control approach, develop a fog control, ordinary requirement control, FSC, implement and enforce. Tiered approach implementation, focus one, new and renovated FSC and FSC areas of collection system experience, sewer overflow and more frequent maintenance, because you should have a control system in place, right? That is what I was explaining. Every restaurant, they must have an fog removal system, oil and grease. If you are just discharging it to sewer line, who will take care of that? The system would just block everything. That will cause the havoc in this treatment system. So those things are important. These are the issues with the small industries and also the some of the commercial entity. Also, I am talking the commercial entities must be brought under regulation. You should have a regulation to control this in a right manner so that the main treatment plant won't be affected, right? Municipalities which collect overflow data reported fog to be the cause as much as 70% of the sanitary sewer overflow. That is assessment. It causes a sanitary overflow. That is why those things are important. Fog control every city must have. You can understand how important this is. You have to have a regulation, but that is what I was telling. Even in a town of 5,000 people, they have this system in place. You can understand how much is the resource, how much resource is spent on this system. Everything is controlled. Even in a population of 5,000, they have this system in place. They have a wastewater treatment plant, they have a drinking water system. So you can imagine how that system, how the system is implemented and monitored properly. Similar system we should have if we want to have a good quality of water and if our rivers are protected, if the environment is safe, right? So prevent sanitary overflows. That is very important. That frequently occurs in the rainy seasons, where if you don't have any capacity to just overflow, reduce the amount of fog discharge to the sewer system and influent to the plant. Otherwise, what will happen? It will just end up randomly everywhere. If they are connected to the sewer system, that will that will spoil the entire treatment plant system. Okay? Reduce the maintenance cost of the fog in the collection system. If you taken care of this fog, your treatment plant system will work properly, right? It has a benefit. So that is why you have to see this overall holistic system for the wastewater management. Resources, reach out to the other jurisdiction. They have implemented a fog program. Fog control is specialty of the pre-treatment. Attend fog training. People should have a training. If you don't know that these things occur, then how we will do, right? How many these fog systems has been cities have implemented? You can imagine the damage to the public infrastructure, is it? You spend crores of resources, crores of money and manpower to handle the wastewater at the city treatment plant, and if this thing occurs and if it spoils the very efficiency of the treatment system, so what do you expect from this? It's a big failure. So that is why all these components are related and they should be brought under the system. And people who are involved, they need a continuous training. People who have done 30 years back, you understand how rapidly we are going and how the treatment system is going in almost all areas, right? How it can be monitored. We have an online system everywhere. Sitting at the one place, you can watch what is happening in the treatment plant system, right? So that is how precisely, if you maintain, then the water quality you can expect. So and tracking emerging contaminants, I will talk very little about this. Then as we go on, you will understand. We talked more about the metals, priority pollutants, PCB, PFAS. These are the next stage pollutants, right? What are the sources for this? You know about BOD, COD, and also yesterday we were talking about the COD, because what happens, biochemical oxygen demand, in the sense it is almost 80% of the waste, is organic and it is treatable. If it is COD, means industrial wastewater discharge always has a higher COD, right? There are certain things which cannot be degraded. So that is why we put a COD into that and make sure how much is biodegradable, right? If you have a biological system, if it is not biodegradable, then it will cause a problem, right? Then you should have some pre-treatment system in place so that it has to be taken care of, then the city can. Or few samples, depending upon the industry, where every metals, organic compounds, inorganic is analyzed. We do it on the chromatography, right? They are in a very small quantity. You want to understand what is there in the wastewater, whether anything is missing which is going to cause a problem. So based on that, you will revise. You will revise the authorization and you will put the limits. You will make sure that it is taken care of. So that is the priority pollutant scheme. The sanitary sewer overflow system, I have already explained much about it. See, if you are not designed the sewer system properly, it will cause an issue. Capacity management, operation and maintenance is very important. So in our system, they have to, every city has to report how many times there is a sewage overflow. They have to notify. If it has occurred, how they have taken care of that. If it is occurring repeatedly, then you need an evaluation. Then you will see that the respective authorities will see the system what you have built is inadequate. So you have to enhance. So that kind of a decision. When you will make that decisions, if you have a numbers, right? If you have proper measurements, if you have a representative measurement, then only you can decide, right? That is what the intent of this. Then I have explained about this spill out of the manhole into the homes, businesses, priorities. Some examples are given. Just if it is overflow, some sewage is coming out of the manhole or from the sewer system, it is flooded everywhere. It will contaminate your drinking water and unhealthy atmosphere. Is it? People will fall sick. You might have seen many examples where the sewage is just left open. Nobody is taking care of that. So indirectly, we are spending more money on the health system. I said 80% of the diseases are from the water itself, right? If you are not spending here, you will have to spend there. That is why it is very important to make the planning for this thing, right? Maintenance is important. We should not wait until repair. That is what we do. There is no maintenance. Once the system stops, then we will start thinking. That should not be the case, right? So, for example, if the car has a problem, you will do the maintenance, then it will work properly. Everything is like that. So proper maintenance has to be there. So release of raw sewage from the sanitary collection system prior to the treatment plant, that is possible. There are many industries. That is why I was focusing yesterday on the survey of the industry. You must know who is discharging how much. You have designed a system, and there are some industries which you have not, they are not in the radar, and they are discharging a lot of wastewater, and it is causing this issue. That is why you have a system in place to understand who is discharging, which is the industry, where it is located, what they are doing, how they are taking care of the wastewater which is generated. You must know. That is why the authorities' first job is to find out who is doing that. If you don't know, somebody is doing and others are just suffering, all people are suffering, right? So that is possible. That is just one example I have put. Some numbers, is it? For US Environmental Protection Agency has this: inadequate base flow capacities, power failure. They have, why, how they are able to have this data? Because they have a system in place to track everything. That is what I was trying to tell yesterday. They have established a system where everything is tracked properly, right? So that is why they were able to come to this. You should know where the problem is, right? If you diagnose it properly, then you can give a treatment. If you don't know what is the problem, then the solution is far away, right? But in certain cases you know very well, but you don't want to do anything, right? There are many examples, several examples. So we should have a proper system in place. Here also we have system in some place, and major places we don't have. So it has to be more focused, and well planned system must be in the place to have all these numbers. Then you can make a determination and decision, right? Inadequate base flow and pipe breaks. See how they know this, how many pipes are broken in the city, town? Do you have any data? No. That is why I was telling you the system is built such a way that how they come to know that the pipe has broken? Because they have to report immediately. They have a database system. In this state, in this town, how much is the pipe breakage occurred, when it is occurred, what they have taken. So they can track everything. So that is how, these things are important. Excessive infiltration or inflow, pipe blockage, because that is what I was telling you. Every city, town, if there is a blockage or overflow, that they must report. Correct. So that is how they get the data. So then they make a plan for that. So overall, there are some certain cities, see, they may not be having a funding, then they give a funding to them. It runs like an business, like a system. If a city doesn't have money, they give money, and people will collect the taxes, and then they pay. They help also. But that kind of a system must be in place, right? And see, how serious is this problem? 19,500 municipality sanitary sewer system in the US. More than half of the system have a peak flow, and reporting SSO even is incomplete. They know. They want to know what is happening. They have a record of everything, who is doing. That is why, see, somebody is doing and others are suffering. How it is. So these numbers help you in the planning, right? Protect the public health. That's what I mentioned. If the severe breakage is there, children and young people can resist if we have a good immunity. But what about the children? What about the aged people? They have a less immune system. Immune system is less for the children and old people. So they will be the sufferers. That is why if you build many medical institutes, if you are not taking care of the basic things, that will go on adding, right? So that is why these things are important. Prevent the public and private property damage. You might have seen during the flooding and all what happens, right? And prevent resource damage, surface water, fish, shellfish beds, groundwater is also affected. That is another issue. A little portion we will deal with the groundwater, how it is affected and how it is important, right? These pollutants, groundwater contamination also there. I have added little tutorial on that. So if the contaminant percolates, joins the underground water, people drink the bore waters, well waters, they are affected. So there is no escape. If you are doing something here, it will reflect, right? Why are SSOs prohibited? Lost recreation value for waterways, lost tourism and sports fishing dollars. They also calculate how much it is affected. If it is a contaminant water, people will never go there. It will affect. See, you should have the understanding how it is affected, right? So this is how it is possible, natural resource, and is some kind of an data you must have to plan that. So where is the problem you should be able to diagnose. This is for recreation and tourism purpose, sports purpose. But there are the SSOs will create a health issues which are more severe. We are focusing on that. So there is a next step ahead. What will also have an adverse effect on this kind of activities. Right? There are much benefits. You can say you should have a framework for prioritizing repair and rehabilitation effort, improved recreational opportunities, reduce risk of public exposure to untreated sewage, reduce long-term rehabilitation cost, improved collection system performance. So if you prevent that, there are multi benefits out of that. So that is what these issues. Cost of SSO control, rehabilitation needs, value of existing infrastructure, replace of existing infrastructure. So that is what I mentioned. You should have, once you have a data, then you can understand if it is occurring number of times, then they can say they have to revise. It is also possible on not only on industry side. Industry sides, they pay a lot of money to the city also. Then it is your responsibility to provide a proper infrastructure also. Then you have to revise your entire the city's sewer system, right? So that is what mentioned here. Personal hours required to implement these kind of satisfy these kind of requirement. So it needs lot of resources. How much resources we have, how many departments we have, how many people are there, what they are doing, is it sufficient? The infrastructure what we have to deal with the wastewater produce, is it sufficient? First we will have to assess that. So they have that kind of an assessment. That is why they have gone far away to assess the minute things, how we can implement. So we do that. Any cities, I said I work with the many cities, they report any sewer line. We'll say what happened, how it happened, what is the problem, is it occurring, how many times it is occurring in the year, right? Then you can ask for an evaluation, whether you're, I mentioned about they have to hire a consultant, a professional engineer, make sure that evaluation is done properly. Then you need a report, then you can take a determination, you can make a determination, right? here once they know, then they can target how many cities the sewage treatment plants are prone to this kind of activities, whether then is there any issue with their funding, or whether they have a lack of resources, whether it is an inadequate infrastructure. Accordingly, government also comes step forward to help them, but it is ultimately they have to pay back, right? That one should have to pay for the wastewater produced. How you pay the um, some money for drinking waters, right? Similarly, you have to pay a lot of money for taking care of this wastewater also, right? Capacity management, operation and maintenance programs. So under this Clean Water Act, they mention how they should take care of all the components related to the sewage system, right? So SSOs are an indication of violation of the proper operation and maintenance caused in the permits or the authorization given. See, if it is we are violating frequently, then it is an indication that the infrastructure is inadequate, because you have designed a system for 100,000 people. If the population goes to 300,000, you can't keep the same infrastructure. It is possible sudden a group of industries come into the place, sudden increase in the population. When there is a sudden increase in the population, all requirements are also increased. In that case, you cannot keep the same system to take that much increased load, right? So how you do these programs are incorporated into the system? Better management, operate, maintenance, collection system. You should have a good collection system. Should have a manual. Designing a sewer system is not that easy, because the terrain also plays an important role. The volume also plays an important role. So you should have a proper system to collect the wastewater, right? Then only you can take that the wastewater produced from the residential and commercial entities to the treatment plants, right? So that is why you should have a better management operating system and a collection system. Investigate the capacity constraint area of the collection system and proactively prevent SSO. See how much importance is given for that, which will cause a severe issues in all direction. That is why this is one of the requirement, and very actively dealt with this kind of SSO events. Then overflow response, contingency plan, grease control program. See, overflow response in the sense, if overflow occurs, what you will do? What are your actions? There should be some action in place. So that is why you have a system in place. If this kind of incident occurs, then how these incidents can be dealt? You have a preparedness. So that is what also that plan also must be in the place. I was talking about the grease control program. This is one of the major cause also. If people are just discharging without doing anything, that will cause a sewer overflow, right? And sewer system assessment rehabilitation program, capacity certification program. Sewer system assessment, yeah, that is what I was telling you. You have to do evaluation whether the system is sufficient or inadequate, right? Then common programs, pump station, inspection, operation, maintenance, information management system, sewer mapping program, all must be in place. If we have a proper collection system, then only it will reach the treatment plant. So you must understand what are the different. I'm first talking about the sewer system you have in place, then the treatment. Then once it reaches to the treatment plant, then you can treat. If you don't have a system in place to collect the wastewater, right, then how we will treat the wastewater? First job is to design a sewer system in place for city, towns, or any industrial unit. Then you can go for a treatment. So that is why you need a pumping station, inspection. Pumping station, why you do? If it is a different level, one sewer line comes here, one is at this level, you have to pump at certain possible, because you want to have a gravity flow always. You cannot keep pumping in a inevitable situations. You can have a pumping station, right? You have certain states, you have seen the cities, towns are built on the slope. So in certain cases, you can't expect the gravity flow. That is why the pumping stations are required. Then every proper program should contain the following events. Must be POTW specific, wastewater treatment plant specific, must have a purpose, must have a defined goal, and must in writing. See, you must put all this in writing and open what you are doing. Everybody should know what is going on, right? It is not that some corner, because public is very active. Public is very active. We just not bother of some of the things which are happening around, right? But the public is very aware of that. Must be implemented by trained personnel. The person who is implementing, he must be trained. He must know what he is doing, whether he is qualified, he is the right person, he has a proper training. That all has to be seen, right? And they must have a performance measurement and must be subjected to periodic evaluation, right? You have to evaluate every time, right? Otherwise, how you will understand the system? So I think this is the lecture 3. What we studied in this, I want to just summarize. In the first portion, lecture 1 and 2, what you studied about the regulatory system in place, right? How you manage. There must be someone to oversee, right, when a system is built. So that you saw. What are the different components? Okay. Okay. That's you have a 15 minutes break at 11:40. Okay. Because I have told them to send a chit like that. Sometimes I may not stop. I may continue. So that's why I have told them, you have to send me a chit. I should understand when the break is. I don't want you should be deprived of food or tea, anything. So, right? We studied in the lecture 1 and 2 what are the various systems, how they operate, how they built the system, how they brought all the components of the wastewater treatment and into a common platform to have a safe environment to achieve water quality, right? You have seen the very administration system, right? There is no loopholes in that. Everything is tracked and you will understand what is going on. Everybody has a right. Every person has a right. In the lecture 3, what you studied? You studied how this wastewater is collected. You have a treatment plant. You have a lot of regulations, how they have to treat, how they can take care, where they will discharge, what they will discharge, what are the components, what are the limits, everything is there, right? And now in this, you studied the collection system. You have a collection efficient system to bring the wastewater produced at the service area. Is in the sense the city has a jurisdiction. If any industry or any residential, any commercial entity built in that service area, they should have a sewage system, right? So if you have an efficient sewage system, then you can bring all the wastewater to a certain point, then you treat, right? And you also saw the consequences of the importance of the sewer system, how efficient it must be, how you will evaluate what are the different components, how you will have a maintenance system, how you what you need you need a large quantity number of trained people to manage the system, right? Yeah, then you can avoid any the overspill and the different causes of health issues to the people in case of spillage and the overflow. You should have a system in place to take care of a storm water, and all that is covered in the this lecture, right? So do you have any question?
for the data collection for the power failures, pipe breaks.
Yes.
I mean, man working can be sometime minimized by using some advanced technologies for
Right.
best water management.
Right. There is a system in place.
Yes,
In many places, we have an online system to monitor the entire sewage system, how it is collected, from where it is collected, how your treatment plant is working. You can see online. And now it is connected to the AI. Many companies, many cities have come forward to put AI. AI is a very good tool. So it does a very good job. It can reduce the number of people.
Yes, sir.
It can reduce number of people working into a small for that will also come here, right?
Yes.
But we need a lot of employment also, right?
Yes, sir.
So, but this is the very good tool. Many people have bringing that into the system so that they can reduce the manpower. Okay? It is already in place.
Thank you, sir.
Just open the lecture number 4, right? Lecture number 4. I understand you don't have a question on lecture 3. If you have any question, you can ask later also. When you remember, you can ask. There is nothing like that. Okay, no problem. Okay. This lecture focus on the POTW, that is the wastewater treatment plants, and industry and waste management, right? So we are going to study what are the components. I have mentioned what are the various component of this wastewater, industrial wastewater management towards sustainable and safe environment, right? And the system should be create in a safe environment, and at the same time it should be a sustainable, right? What you design, any treatment unit or the treatment system must be sustainable. What are the various components of this? Components of all permit means that is the authorization given by the regulation, right? You give an authorization for industry. Right? Here also there are many regulator bodies issue the permits, right? Licenses, right? Authorization to discharge. That is the word which is synonymous with the permits, right? The components of specific non-POTW, effluent guidance, case-by-case limitations. I have mentioned about this. You have a system where the guidelines are given to you, how to do. And there are certain situations, a new industry is coming into the town, and some of the discharge pollutants, contaminants are not traced in the beginning. Then you have the authority initially by your best management practices, judgment, you can assign certain parameters to be monitored. Then once you know, within a period of 6 months or a year, you will understand there are certain things which are causing an interference or pass through. You can also modify the authorization and put more limits. So that is what case by case limitations, right? And what are the various components? Effluent limitation, technology based, water quality based. There are certain technologies are implemented for taking care of the wastewater. In certain cases, you are not sure about the technology because there are certain pollutants you are not well developed. There are certain cases with me where I have dealt with. You don't know have a available technology to treat it to that level. Now you are aware of treating what is the BOD, what is the TSS, what is the ammonia, nitrate, is it? These are the common, some of the parameters you know. If I say there are certain components which are in terms of 0.00 milligram per liter, many of the environmental background people might can understand. So how we will measure? Right? We use a different equipments, gas chromatography, HPCLC. There are certain things. You want to study some what kind of a bacteria exists. You want to know, is it different type of bacterial growth which are used in the biological system. You want to know whether you are really treating or it is ending up in the sludge. That is why we do a sludge analysis. The first question, the treatment is not kind of an unknown box, right? You must know what is happening in the system, whether they are really treatment is going on, where it is going, converted into organic compound is converted into carbon dioxide and water, right? Then in certain components, where it is going, converting into what? You must know the chain reaction, what is going on, right? So that is how you need some technology based, and for a known thing, the water quality based, you know certain certain industries produce this kind of a wastewater, you can put directly, you can put a BOD monitoring, you can put a suspended solids. If it is some kind of a food producing industry, you can also put nitrates, right? So that is what is said, technology based and water quality based monitoring and reporting, special conditions, additional monitoring and special studies. Sometimes you want to conduct a special studies to understand more about the wastewater discharge, right? You cannot just say the industries, oh, we don't have any regulation for that, but you have tools. You can say it is a new one, so we want to put these are the parameters based on how we will do that decision. As a scientist, as an engineer, as an expert, you will see what are the raw materials used, what is the product. These raw materials, when they are used in the production, probably these may be coming into the effluent also. So you will see, you may be wrong, then you will get a no detection for many months. Then you will say you will modify. This is not required. That has happened in many cases. There was a situation, another 5 minutes. There was a situation with me there. This was a big coal mine industry. People in the regulations, they monitored BOD, COD, nitrate, other things for many years, right? If you don't pay attention, suddenly they came to know that the selenium is also one of the contaminants. Because what happens in the coal industry, you take the good stuff in that and the rocks will be stacked. Then when the rain occurs, all the selenium started entering the water system. You will, at one slide, I will show you what are the effects of these contaminants. Is it? So they were not knowing. Many years you just kept on measuring the some of the substance where BOD is 150, 150, 200, and suddenly you came to know this is existing. Oh no, this is about 10 milligram per liter, it is harmful. We want to put a regulation. But do you have a technology to take care of that? You cannot just tell the industries that you put a 10 milligram, there is no technology available at that. That is why it occurs on this side also. That is why the constant evaluation, understanding about the wastewater, what is coming into the system, right? Otherwise, you wasted lot of time here. Then they said you cannot put the limit immediately because you want to first understand how much quantity it is available, whether it is in 40, 50 or 100, 200 or it is 10. If you don't know, how we will come to that number? When you put a number, you have to be serious. Like, you can say things are good. If I ask you what percentage, then you start thinking how much I should say. That is how it is. So these things occurs, special condition, additional monitoring, special studies. Then they say they put a group of smart people to study this, understand. They put a lot of resources into that. In a period of 2 years, they will collect the data. Then they will come to an understanding. Oh, this is the range in different kind of coal mines. Then we can put this much is the limitations, right? So the special studies are done. Component specific to the POTW, secondary or equivalent to secondary pre-treatment, municipal sewage sludge, CSO, and all these things you will study in the biological treatment. Sludge is also an important factor to be taken care of that. Once the wastewater treatment plant always produces a sludge, you must know what it consists of, right? Where you want to dispose, what are the contaminants in that. So that is how the municipal sewage sludge management is also a very important component in the system, right? Okay. Now we'll give a break. Enjoy your tea and coffee, relax. Then we will continue. Okay. Thank you. understanding about their engineering, the way of dealing the issue. I have put some of the case studies. So these were the situation we how they are taken care of. Biohazard, or if the treatment plant was not capable of treating, what happens? It will end up in the introduction of pollutants into pure TW, that is the wastewater treatment plant, which to grow certain plants there. He was putting a small. Today you will see a large scale in the tutorial. It is already done. Many wastewater treatment plants, they treat the wastewater and it is applied to the land. Will give you example. Many like that. That is the trend in many places, right? Big your computer industries, like they use a lot of water for air conditioning. That water is treated, recycled, and they use it for various purposes. That water is recycled, then discharged. So those are some of the things. What are the different components here? Industry, discharge wastewater to the wastewater treatment plant. If it is passed through, it will come out here. Hazardous, it may create a problem if you are not taken care of. It will also cause the sewer systems will be spoiled because of corrosion. If a low pH wastewater is discharged, then it may cause an interference. And there is a limitation. Sludge which is coming out of the treatment plant is the sludge and biosolids. If it has a contaminants, that very sole purpose of the objective is destructed, right? There are some numbers. The production and utilization. Nationally, 7 million dry ton per year. Regionally, 100,000 ton. And state, rural state, and urbanized state. And one way estimated your dry treated biosolids production 0.35 to 0.5 per mg, right? That's a million gallons. If you have that much capacity treatment plant, approximately, this is the biosolids produced, right? You should have some number, how much. So that will help you to understand how you should design the system, what are the various components to be considered in designing this kind of system. I've given an example. A facility treated 5 million gallon per day capacity. It's in the gallons. If you convert that with 3.78, then it will be in MLD, right? So should produce about 640 to 900 ton per year, right? So that is just an approximate number. So 1% of the cultivated farmland could be fertilized, right? So this produced biosolids can be applied to the farmlands, right? There is some national biosolids use and disposal. The one report I have referenced that shows disposal, surface disposal 33%, 45%, and 22%. Is it? I think this number is messed up here somewhere. We'll see, we'll rectify that. The classic and the incineration 15%, surface disposal is 2%, reuse, disposal, and how much comes from the agriculture, reclamation, and forest, range land. This is given some number to understand how much is the contribution. There are certain biosolids where if it is a contaminated, what you will do? Then You have to incinerate. Right? That is why yesterday I was telling of wastewater coming from the hospitals, clinics. It has to be incinerated, however small it is, right? Or any clinics, everything should be incinerated. If it is contaminated, you don't have another way to treat like that. So if that is why how important is to prevent the toxics entering into the systems. This is another number, current quality 2006 biosolids data when compared with the typical soils. This will give you a kind of a understanding. Regulated contaminants. What are the contaminants? We are talking about chromium is also there in that. And mercury is there, nickel, selenium. We were talking about the coal mines there, selenium is there, chromium is there, leather industries, right? So you know the source from where the contaminant comes into the treatment plant, right? And these are some of the numbers and typical soil concentration and national data on USAPA region and particular region. They have given data how much is the contaminants in a 1 kg of biosolids, right? That will give a kind of understanding. Then regulating biosolids in the NPDES permits. NPDES permits in discharging it to the rivers, right? Regulating biosolids, you must have a law first. Then only you can monitor. Otherwise, you cannot monitor. If there is no law, you cannot take any actions on that. So, self-implementing, there is in a particular CFR where you can find the related regulation about the biosolids. Must meet the requirement even when not in NPDES permits. Even if it is not in the permit also, you must meet the requirement, right? Permit may contain a state requirement but must be met at minimum of 503. That is the requirements, state level requirements are different, may be different. Requires reporting regardless if in the permit. You have to report about the biosolids production, whatever the tests conducted on the biosolids. Even it is true for the treatment plants. If they are producing a large quantity of sludge, you can also put the monitoring of the sludge, right? Yesterday we visited a treatment plant. You see, there was a sludge producing. What is said, when it is treated, the solids will come down in the form of sludge. But how we will take care of sludge? For them it may be difficult, because if it is produced in a small quantity, they cannot have a treatment unit for sludge. In a large treatment plants, you might have seen what happens. Wastewater is treated, it enters the different trains of treatment. The sludge from the primary and secondary containment, it goes to the thickener. The purpose of thickener is different from the secondary treatment. There your aim is to remove the sludge, remove the suspended solids. But here your aim is in thickener, your aim is to remove the water, correct? It passes to the thickeners, then you separate the solids and water. That water goes back to the system. It is recycled for the treatment again, and that sludge treated, comes from the thickener, is taken to the drying beds or to the different purposes. Then that can be further developed into a manual, right? So implementation of these permits for the sludge, it is not only important to take care of the wastewater, and the sludge produced from the wastewater is also important. There are regulations for that. If it depends upon the volume, whether you will have to evaluate whether they need an authorization requirement, how to dispose that sludge. If there are many companies which, if they are producing a small sludge, if it is a toxic, there are companies where they can collect from different treatment plants, different industry, and they can build their own treatment plant. Make sure that it is contaminant free, then it may go to the landfill, and then it is taken care of. There are different regulations. If it is a toxic, hazardous, that is a totally different, comes under different regulations. Then when the sludge is produced, you have to make sure that it is contaminant free, then you can apply for the soil. There are people, many participants from the soil background, so they must know how important, when a contaminated soil or contaminated water is applied to the land, what consequences it creates, right? So that is why we are taking care of the water also, and you have to take care of the soil also. So both are very important, right? Most of the states have adopted, that is this part specifically deals with the biosolids produced. There are many states which these comes under these regulations. They have applied this kind of regulations to take care of biosolids. Then current federal rules impacting the sewage sludge biosolids, they have given a list of laws, right? How they are developed, they have taken a number of samples, they have put a lot of efforts to develop these regulations, right? You have to have a lot of data to develop, understand what is required, what are the contaminants, is it, how the limits are developed. How the limits are developed? Initially, you cannot put the limit. First, you should understand each industry, what is the probable amount of the toxicants or the contaminants are produced. Then you can decide how much we can sustain. So that is how the limits are developed. There are many regulations which deals with the municipal solid waste. Landfill requirements are different. We are also the landfill, 30% of the current biosolid productions. You have seen the landfills. Landfill portion is not covered in this. But you might have seen many of the landfills in different cities, towns, especially bigger cities. We don't have a perfect plan, but which are those landfills are done long back, but they have enough regulations on that. The how to take care of the solid waste, how to take care of the landfills. All the landfills ought to be must have a secondary containments. Earlier, just they used to dump the solid waste on the ground. That has caused a severe problem. But now, after the regulations in place, they have to be geomembraned. They should collect the leachate. You should have a second 2 layers, double layer containments to collect the leachate in the beginning. Leachate production is high in the beginning, and then it will slowly reduce, right? Then and there will be a liberation of gases also. If it is if it contains organic compounds, then the gases regulations will be there. After a few years, these landfill will become golf courses. You will be playing on that, right? You have seen many places that way. So those are all, there are regulations to take care of the solids, the wastewater, and also the soil, right? This slide specifically highlights, to make you understand, there are regulations to deal with this also. There are guidance documents, how to develop the limits, how to take care of the contaminants, right? Then methods of biosolids and land applications. You have seen many examples. Their waste, if it is not contaminant, they are used for different purposes, right? And the wastewater is also used for spraying on the large agriculture lands if they are contaminant free, you have seen. And also if it is contaminant free, if it has a lot of soil contained soil in that, then it can be used for road constructions and right, for many other purposes. Generalized area of 503 coverage, general requirements, pollutant limits, management practices, and operation standards, frequency of monitoring, and record keeping and reporting. These are all covered under these regulations. Any solid waste which is generated from the treatment plants, they are covered under this. It should be pollution free. It should be have a good management practices, good monitoring system, operation standards, and how much frequency, what should be, what is the interval of measurement, and all are important to make a determination it doesn't have any toxicants in that. Land application, metal waste classifications. See, if it has any metals in the solids, you cannot just apply on the lands. Is it? What are the different type of maximum concentrations are given in the table here. You know the list of contaminants. They come from different source of discharge, different industries. Based on that, you have the contaminant concentration, how these contaminant should be taken care before you do the application, right? Yes. Unit? Oh yeah, a milligram per kg is the unit. I think is that missed there? Yeah, that's good. Good, right. Maximum. I think it has gone milligram per kg, right? It has just merged this one, right? And pathogen destruction is also there. If it has a lot of pathogens in that, if it has a bacterial load, how you will take care of that? One is the contaminants. That is also an important factor in case of biosolids. Another is if it has a lot of pathogens. A lot of people from a biological background, they can understand how much damage they cause. You cannot just put this, biosolids which has pathogens and on the land. That may cause health issues to the public around. This happens with a lot of landfills nowadays. You can see because of limited space, people just stay around the landfills. See how much exposed they are for these contaminants, right? They may be exposed for pathogens. They may be exposed for metals. Also, if it is not well contained, if the landfill is built long back, doesn't have a ways to collect. During a rainy season, you can understand a lot of water percolates through landfill and enters the underground. Through that, it enters the river. How much damage it will cause. See, that is why I was telling often we have a limited space and a lot of people thickly populated. It is very important for all of us to take care of the water and the soil, right? Then you have seen these vectors, attraction, reduction. You see, lot of chemicals are sprayed today because this will give rise to a lot of mosquitoes, vectors, people living around them. there is a complaint, everything, right? That what they do, just to keep the public calm, they spray certain chemicals, pesticides on the landfill. But what happens during the rainy season? Slowly it will start again percolate, because if they are carcinogenic in nature, that will enter the groundwater, ultimately to the river, ultimately it comes back to the people, right? So this slide gives a little understanding on the vector attraction reduction. So there are different ways how you can prevent, reduce, but you cannot get rid of it, right? So if they are not maintained, because today there are regulations where you should have a double lined geomembrane, and once it is landfill is filled, then it has to be covered with the geomembrane, then the cover over there, so that it is not exposed for the precipitation and exposed to the people working around, right? That is how it is taken care. But if it is done some long back, 50 years, but still it is there, you should have a ways to clean that. Requirement at the site of land application. The management practices. Agronomic rates, no harm to the endangered species. When you are developing a large landfills, if it is not taken care, then it will affect some species also. It will affect the human beings, right? So no harm to the historic sites. If there is a historic site, if you have a contaminated river, there are examples here, right? You guys know. So if there is a big landfill besides that, what will be the value of that monument which is built, which is our history? Those things are important to be considered in taking care of this landfill. That is why there are requirements today, how the landfills are designed and how far it should be away from the city. But what happens, initially you will design some kind of a landfill in certain area, and the city start growing that side. So that is why the proper planning has to be there in order to take care of this landfills and the disposal sites. Groundwater protection is important. Snow covered sites, wet weathers, storage requirements, all these are very important components in the requirement, the site of land application, right? Monitoring and analysis of biosolids, annual production frequency less than metric ton per year, once per year. So you need some kind of an frequency to measure, monitor stability of that landfill, is it? So one per quarter, once per 2 months, biosolids monthly, prior to removal. You should have a kind of understanding about the landfill. What is the effects of this landfills to the surroundings? What it consists of? What is happening? How the groundwater is affecting? If a landfill is there, what they will do? How we will measure whether it is discharging any contaminants to the groundwater? You should have a groundwater monitoring well all around. You will see, you will start measuring what is the concentration of these metals, contaminants in the groundwater. If it is a nearby river, you will also do a measurements, whether you want to understand the discharge from any water percolates through the landfill and entering into the river. You need a measurement. Once you do a measurement, monitoring, then only you will understand what is happening, right? If you are not measuring, no measurement, no pollution, right? Everything is fine. So that is why it is important to measure the contaminant concentration. What is that? Data is important. Data will speak for that. If you say that it is causing contaminants, if I say, you know, it is not causing contaminants, the owner will say, or the person who is responsible. That is why you need a data analysis to understand what is happening. Then you can find a solution. So that is what these analysis are important to make a determination and to make a planning on that, right? Then record keeping, on or before this particular year, you should have a report, and authorized state programs report as requested by the state has an authority how you will develop, what they should do, whether their sides are side slope or stable, whether how much contaminant are entering into groundwater, how much contaminant are entering into the river, who will make the decision? You need a thorough study, thorough understanding. Group of people, there may be a third party, many people appoint a third party, expert people, to make sure that you have a proper report to make a determination. So that is all comes under this reporting system, and you should have a proper record, because these landfills last for many years, decades. Certain people will get retired. Then how we will come to know? One person, if he has worked for 20 years, and another person, how we will understand? You need a proper understanding and record keeping. That means what you are doing, you are creating a system. Whether a person is there or not, the next person can start understanding what has happened, what should be, he can take over from there. So that is why this reporting, record keeping is very important, so that the next generation, next group of people can take over the system. Application loading rate, you will understand amount of biosolids produced, what are the components here, concentration of the pollutants, pathogen treatment methodologies used during the year, and the results. You should know vector attraction reduction methodologies used during the year and the results. You know, you applied this, what is the effect? How we will understand whether how much is effective and how much is not effective? How we will come to know? You need a number, right? Otherwise, you will not understand. That is why it is very important to do the analysis. Data are important so that you can make a determination, right? So that is all is covered, and how much is useful and how much is not useful. If you are applying a fertilizer to the crops, right, how much crop intake is there, you should know. How much is draining up? There are lot of people with soil background, they do study. You should what you will do, you will try to understand how much is entering into the soil through that, and then entering into the water, rivers. Is the fertilizer what is applied is completely taken away by the crops? Rest, how we will measure? So those numbers are important to make a determination, the effective treatment given for this kind of activities. Standard conditions and bypassing. International diversion waste streams from any portion of the treatment facility. Bypass not exceeds the limitation allowed without notification. Bypass prohibited, otherwise except. A bypass was unavoidable to prevent a loss of life, personal injuries. There were no feasible alternatives for this bypass. When you do, facility gives the notice before bypass or within 24 or unexpected. These are the regulations how you should manage these kind of landfills, right? Then exceptional incident that causes unintentional temporary non-compliance with technology-based employment limitations. A demonstrated upset constitutes affirmative defense to an action brought for non-compliance with such a technology-based limits. There may be a technology-based limit, there may be a case by case studies, each are different. Based on that, you have to make a determination what kind of planning has to be done in order to take care of the waste produced from these biosolids, right, and landfills. Right. So in this lecture, basically we study the biosolids, we dispose it up to the landfills. If it is good, what you will do? You will use as a manure, correct? I'm just trying to summarize how these biosolids are covered. So far you have studied different regulation system, how the wastewater produced from the industry entering into the sewer system, entering into the treatment plant, and then it is taken care of. You want to make it contaminant free, then discharge, depending upon where you are discharging, whether you are discharging it to the river or applying it to the land, correct? But biosolid is also a component of the treatment plant, right? You should have a regulations for that also. Big treatment plant, they can make a good economic decisions on that. They can use this as a manure production. That is why it has to be contaminated. If it is contaminated, what you will do? You need a space to dispose it of. You cannot just go and dump anywhere, even for a road construction or anything, because you know it is contaminated, because you have measured. If you are not measured, you can do anything, right? Measurement, if no measurement, no pollution, right? If you have measured, then you need a place for the safe disposal. That is why we send it to the landfills. Then there are regulations for that. How you should take care of biosolids, when to use, when not to use, what is the frequency, approximate biosolids produced, and what are the contaminants, how the metals are taken care of. There are guidelines. You need a guidelines how to take care of that, right? What are the technologies, how the landfills are taken care of that. What are the side effects they will cause, whether the waste, because you know when the landfills are just open, imagine a big rain. Somebody was asking a question, yourself, right? If there was a rain entering into the clarifier or in a equalization tank, what will happen? There is a dilution, right? Nothing will happen. Dilution we can't do that. When the contaminant is there, if it is your regulation, if says that BOD is 30, if your BOD is 60, you cannot add a water and make it 30 and discharge. No, dilution is not the solution. It is not allowed. You can make it because you need water, right? Good water you are adding. Water scarcity, you know, in many countries, everybody knows in the cities what is the situation of water. We all depend on this, right? So this is the situation. That is why there are regulations. When you create any landfill, there must be a procedure how to manage them, how to measure contaminants, what must be the frequency, what are effects, number of effects. Groundwater is affected. It may enter river, creeks, and people nearby vicinity, they are all affected. Maybe a half kilometer away, still you are affected. A lot of mosquitoes. Somebody was asking about mosquito question, right? So if you are close area vicinity, there is a landfill, because initially you will plan landfill should be away from the place, but after some years landfill will come at the center. So then how we will get rid of this? You already built spending millions of dollars, the infrastructure around that. That is why people around that, they start spraying and keep it low. When people start crying, then they spray the something to keep it mosquitoes and other vectors down. But that is not the solution. They are also a contaminant. So that is how there is regulations, how they are taken care of that. Not only the wastewater and also the solids. You need a kind of a manual guidance, right? So how where to dispose in these conditions, what we should, you cannot ask a particular person. That is why the regulations are made in this situation, how this is implemented, correct? So that is what all is explained in this lecture. So by that way you can understand what are the different components of our treatment system, right? Solids, wastewater, regulations, and the other stakeholders who are responsible to run this system. So all has to be educated, work together in order to make it successful, right? Then your system will work. So if you have any question, we can discuss about that. We have 10 minutes.
Hello, sir. I have a query. What are the commercial use of biosolids except manuring?
Commercial use of biosolids is in many places you have seen they will pack and then they dispose it. That is the good use of the biosolids if it is contaminant free. If it is contaminant, if it has a contaminants, then it is goes to the landfill. If see waste, I mean the solids which are coming from the grid chamber, it doesn't have any contaminants or the pathogens. Those kind of solids, we use it for road constructions and filling of low-lying areas and all you can do. But when it enters to, it has a suspended solids and it has in the way sludge coming from the secondary, there all has to be treated, right? We have to make sure that it contaminated. That is the only economic value for the biosolids at the current. Right?
Sir, is there any cases of utilizing biosolids for landfill soil cover?
Landfill, what is that?
Soil cover, covering the landfill.
Soil cover. Yeah. Soil cover. No, if it is a biosolids, good biosolids, it can be used for used as a manure for growing crops. If it is a contaminant, you can still you cannot use it. Just you will dispose it. Right? In the landfill cover, we use a clay soil which is less percolating. Then it is covered by geomembrane and we put a clay soil so that the precipitation doesn't enter the system. Right? You want to seal that and then you can declare this landfill is done, ready for other stuff. Right? That is how it is.
Thank you.
So my question is, as the population of India is increasing day by day, and due to industrialization, deforestation is occurring, and agriculture is decreasing for the land. So is landfilling a good way for deposition of the biosolid, because we don't have extra land because of increasing population and industrialization?
Correct. That's why I never say that biosolids should be sent to the landfill. Biosolids can be used as a manure. You can apply it to the land for growing crops. If it is a contaminant, then you cannot apply it to the land.
Yes.
So that is only those things you need a space to dispose it off to the land, right?
Thank you.
It is little bit safe.
Thank you, sir.
Right?
Any method for the purification of the biosolids? even contaminated biosolid used for the landfill, it's also effect on the groundwater.
Yeah, there are methods. What you can do is they clean that water with the contaminants, and they make it, the contaminants are carried out by the water, and that water is recirculated in the wastewater treatment plant, and will try to treat and make it clean.
Okay, okay.
That is.
So I wanted to ask that, is there a difference between burning and incineration? And is incineration a sustainable method of management of biosolid or any kind of waste?
If you see, that's a good question. Incineration we use when it is the highly contaminant solids, right? For example, the clinic, waste coming from the clinics, hospitals, they are contaminants. It has a lot of contaminants. You can just expose to the outside. That's why we use the incineration. Incineration is the last alternative, you can say. So if it is has an highly contaminants in there, contaminated, then you will use incineration. That is the expensive method of treatment actually, but there is no other alternative, right? There are
Managed in certain way, because they, however far we go in management, but there will be some amount of moisture that will be still there in solid way. That is my
where
assumption.
once you do incineration.
No, sir. But how is the unit created that the waste which also has moisture is burned in that unit?
You can burn anything. If you take it to 500 degrees centigrade, it will just burn everything.
So even if the quantity is humongous,
That is why we try to remove as much as possible the water content. That is why the very purpose of thickener I mentioned is to remove water from the solid. Is it? We want to remove water from the solid, then it is recycled for the treatment plant, and the solid is then taken off. Even if we are using it as a manure, we remove water content in that. We want to make it dry as possible. You cannot make it 100%. That is why one of the earlier method was to use drying beds. If the temperature is high in certain areas, they used to make a drying bed, keep it for many months until the substantial moisture content is removed, and then once it becomes dry, they can use it as a manure. That is how they used to do.
Thank you, sir.
Hello, sir. I had a query like that. Yesterday, you told in the subject that in your lecture that we are using the water haulers to carry the sewage water from the small cottage industries to the treatment plant. They are collected from there. If we build the treatment plant in the cottage industry or the plant which is in separate area, like distance from the cities, and treat the water at there and use the treated water in the flushes, like most of the water is used in the flushes in our bathrooms, and the biosolids in the in growing the crops, then sir, how would be it if we propose a memo to the government, or if the government provide the subsidy to make the power plants in the small cottage industries or the institutions that working on there, and no water haulers or water transport to the treatment plants, like we are creating a solution inside the institution or the cottage industry.
I did not understand the question. Can you shorten this?
Yes, sir. Like making the treatment plant inside the industry and using the water itself, so that water shortage will be.
Yes, right. I understand.
And also the biosolids used in farming, sir.
Okay, sure. Many industries today, there is an very economic value that it has. They want to treat the wastewater and recycle, right? Recycle and make use of it fully. There are many industries. That is why water reclamation, right? In industry also they do. There is, I remember one Microsoft company that they use a reverse osmosis process to treat the wastewater which is produced and recycle 100% loop, complete loop. They use it as much as possible, so there is no discharge. That is possible. You have a system. That is what the reuse recycle. That is one of the important aspect. We have one example like that. I will take. So where this water is treated and reused, and even we have done in many industries, they treat the water, treat the wastewater, then we use that treated water for application to the land for growing crops. There are many examples. I am also going to take that. You can also, anybody in the tutorial, you have opportunity to share your thoughts, share any example also. We can have a kind of an interaction on that. There are many examples. Today, that is the one of the prominent development in the wastewater world. We want to use recycle, reclaim, and reuse the water. So that is happening already.
I want, sir, that like the government also support the peoples, like providing some subsidy to the industry or the small industries to make the self-treatment plant.
I think there may be, I don't know the subsidy here, but there are maybe some you can say some benefits from the government also if they are using it. It is quite and industry itself saves a lot of money. Taking water from the sources itself costs too much money, right? Right. We will take some tutorials. I will tell you how successfully it has been done in a very large scale. Right. Okay.
Thank you, sir.
Hello, sir. These biosolids can also be used as a sludge briquettes, so that it can be used in blast furnace as a sustainable fuel source in place of burning coal and all. And two advantages will be in place of dumping in landfill, it can be turning into briquettes, and one more thing will be exploitation of coal.
It depends what is the
what kind of
thermal
biosolid
value,
it is.
thermal value of the coal, right? Thermal value of the coal, I think you guys have what? She can answer that question very well.
Actually, right now research is going on in the direction of the blending of solid fuel with the coal fines. Not exactly just the briquettes of the solid fuel, purely solid fuels, but we can do the blending, sir. Blends of some portion of the biosolid plus with coal so that its thermal value can be maintained.
Yes,
and exactly. It can use. And so one more thing is that rather than just go for the solid fuel, right now research is also going in the direction of green hydrogen production by using of that biosolids.
Very good.
That is in a very nascent phase, but still we are in a few places this work is also going for the green hydrogen production by using the biosolids.
Correct. So thermal value is important. What purpose you are using, how much blending has to be done, like that, right? So the another example is for organic waste. We do an anaerobic treatment and methane is produced, but methane doesn't have that much thermal capacity. That's why we blend that and make it sure that it has a proper thermal value so that it can be used as for a cooking gas or as a fuel, right? That is all.
Hello, sir. You mentioned a slide in which you share the data of US that this amount of daily biosolid they produce, but in India this value is not identified. How we quantify this value?
Okay. That is why you have to generate. You have a system in place to do that. You can adopt the same model here. You need all resources, people to take care of the wastewater produced, biosolids produced. Then only you can make a determination. That is in a very initial conditions. Then step by step, I think all of us should work together to move it forward.
You also mentioned that this amount of arsenic is present in biosolid of USA.
How that is generated? Because they have a measuring system.
Yes, sir.
They measure everything has to be reported. If that goes into a database system, that is why we are able to find out how much is the contaminant in this. But if you don't measure, no pollution.
So if we measure that the same amount of arsenic value is found in India.
No, it may be different, but I am telling you, you can keep a track. Then you can make a determination, right? Once, if you do not know how much is the produce, how much is the contaminant present, how you can make a solution for that. That is why those data are important. If I say, I was giving an example, if a big landfill is there, yeah, there's a, besides it goes to the, it may contaminate the groundwater, it may be the river. If you measure, then you will understand what are the contaminants, right? That is why the measurement and the proper plan, procedure, regulations and all, they are important in order to understand what is the contamination level. That is a very important aspect of that, right?
Sir, I have one more question. And how safe it is to use that treated industrial wastewater, that too for this farming? Because we know about this trophic level and pollutants, that is bioaccumulation and biomagnification. And some of the heavy metals, trace metals will be there in food, and that too in metropolitan cities.
The wastewater which has any metals, it cannot be applied to the land, first, number one.
Okay.
Right? If you are not taken care of the wastewater properly, ultimately it will end up in soil or in the river, and it contaminates the water.
Exactly, but not every industry will be having a tagline like ZLD, zero liquid discharge industries, and some industries will be discharging, and finally it ends up in water sources, and it contaminate, and it will be entering this food chain.
Definitely it will go into the food chain, because if there are some pollutants which are carcinogenic in nature, if you are not taken care of them, it will end up in the soil or in the water, and ultimately it enters the food chain.
Yeah.
People eat fish, it may enter the fish.
Yeah, that is
right?
biomagnification.
Yeah, that is possible. That is what is happening. So that is why it is very important for us to take care of the wastewater, right? Contaminated water. Contaminant have to be removed and then discharged.
How to make sure that the water is safe for agricultural activities?
No, you can do a measurements. Wastewater, before applying to the land, you have to make sure that this water can be applied to the land. It is not drinking, not only the drinking water is measured. It is also, when you are applying it to the land, you should make sure that it is contaminant free.
So
if it has for example, nitrate is there, then some portion of the nitrate is taken by the crops and some portion is remaining. You have to make sure that this is not causing any pollutants to either to the groundwater. That is why we make sure that how much is the crop uptake and how much is entering the groundwater. The component which is entering the groundwater is not causing any groundwater pollution. That is why the measurements are important for that. And you will also monitor whenever you are applying the wastewater to the land. You will measure the you will take the soil samples and measure how much is entering into the soil.
But I don't think this is happening in India, right?
It will happen.
Just I will interfere here.
Yeah.
Yeah. At Pantnagar also, we have some research projects which are going on at Environmental Science Department. I think the students can highlight that thing. Okay. That whatever that domestic wastewater I am talking about from our colony called Ta colony, if I am right, entire that will be collected and that will be passed through a canal Okay, means constructed thing, and then they will put up a series of natural trees which can treat that wastewater. It's a natural treatment. No pumping, no nothing is there. It is just due to gravity only. Sometimes we are taking serpentine such that residence time will be more, so that all those particles, so they will be absorbed in that land, and that land also, yeah, some of the domestic wastewater is fertile. You can, I think if time permits, we'll take you over there also. It is just a walking distance from here, because there is a smashan is there. Okay, smashan means a crematorium. Okay, so near that you can just observe how that quality of wastewater differs, and also how the trees growth is also different. Some of them, they are 5 years old, still you can observe over there the difference and other things. Yeah, they are testing. It's a part of our, I think, DST project, and also some it's an international project with Netherlands. They are working. Whatever you said, yeah, they are testing the inflow, they are testing the outflow, and then that water will be released to the river or stream, I should say, of our Pantnagar. I think Beni River, no? Huh? Huh? That the river, they will discharge it. So they will test it, and then only they will put it. And that water is used for agriculture purpose also. Agriculture means, like as I said, you can see those trees. You can observe the difference based on nutrients. It's a domestic wastewater only. Okay, from our colony. Sorry.
Thank you.
I think we should stop. Stop. One of our Doordarshan Uttarakhand.
We will try to many things from our resource person, my colleagues,
Hi.
and many new things I learned. Yesterday, we visit to Sitkul Industries and saw different problems in industrial area, how to manage the waste products of industrial areas. My research work on industrial wastewater treatment. I enrolled in PhD in 2013 and completed my PhD in 2020. So I saw different problems in treatment of industrial wastewater in large scale. At first, we have no lab facility. The first problem is this. Thank you to all. Thank you.
What is your hobby?
My hobby is playing cricket.
Oh.
Okay.
Good afternoon, everyone. Myself, Priyank Pandey. I am from Pantnagar, and currently I am pursuing PhD. Dr. Mahesh Vishwakarma, he is my guide. So, and my educational qualifications are MSc Chemistry and B.Ed. And yeah, thank you.
Good afternoon to all. My name is Venu Bonal and I have done my BSc and MSc from DSB campus Nainital, and currently I am pursuing PhD on from SSGNA campus Almora, and thank you.
Shiva, they are not telling their hobby. We want to know what you do apart from learning or studying or working, right?
Okay, my hobbies are singing, dancing, and traveling. Okay, extra. Thank you.
Very.
Good afternoon, all. Good afternoon, all of you, sir. It's my pleasure to introduce myself to you, sir. I am from Bageshwar. I am a PhD scholar of PGC Verina. Uh, my hobby is spending time with orphan children.
Very.
Thank you.
Hello, good afternoon. My name is Kamal Singh Pindari. I'm done my bachelor's from Kumaon University, Nainital, and after that I am a project assistant in CSIR IGIB. The project is completed in March last month. Uh, so I'm also doing MSc Environmental Science from IGNOU, Delhi. My hobby is playing football.
Very nice.
Thank you.
Good afternoon. Good afternoon to all. Myself Sanjay Kumar Nirala. I am Associate Professor, Department of Soil and Water Conservation Engineering, Dr. Rajendra Prasad Center, Agriculture University, RPCU, Pusa, Samastipur, Bihar. I have 17 years experience. Presently, I am pursuing here the PhD program in Department of Soil and Water Conservation Engineering. My hobby is reading book.
Very.
Good afternoon, respected sir, and to all my friends. Myself, Ketina, I'm from Manipur. Currently, I'm pursuing PhD from environmental science, and my topic of research is greenhouse gas emissions from landfill, along with the characterization of the solid waste and the leachate. And my hobby is playing badminton and also playing music. Thank you.
Warm good afternoon to all of you. Myself Shivani Singh, and I'm a research scholar at IESD BHU. And my study of research is based on the potential effect of liquid waste on soil and plant health. And my hobbies includes dancing. Thank you.
Good afternoon, sir. Good afternoon, everyone. My name is Shreshti Saxena, and I am a bachelor student pursuing fisheries science from College of Fisheries, Pantnagar. And my hobbies are reading and playing badminton. Thank you.
Good afternoon, all of you. My name is Tanu Sonkar, and I pursue my master's in chemistry from Allahabad University. And currently, I am working as scientific assistant in project work from ISDBHU. And my hobby is playing badminton and singing. Thank you.
A very good afternoon to all. My name is Sulbhi Chand. I am a PhD civil engineering student working under Dr. Ajay Prasad. My research work focuses on spring. The title of my research work is Prediction of Spring Water Quantity using machine learning algorithm. And I belong to Uttarakhand, and my hobbies are gardening and traveling. Thank you.
Good afternoon, everyone. My name is Sidra Malik. I am from Kitcha, Uttarakhand. Currently, I am pursuing MTech in Hydraulics Engineering under Dr. Jyoti Prasad from College of Technology, Pantnagar. My hobby is playing table tennis. Thank you.
Good afternoon, everyone. My name is Diksha Arya. I'm from Haldwani, Uttarakhand. Currently, I'm pursuing my MTech in hydraulics engineering from GBPUT Pantnagar under Dr. H.G. Shiva Prasad, and my hobby is dancing.
Good afternoon, everyone. My name is Sumanda Sila. I am from Haldwani. Currently, I am pursuing Masters in Chemistry from GBPUT Pantnagar under Samina Ma'am advisory. Thank you. Yes, sir. My topic is development of electrode for energy storage application. Thank you.
Good afternoon to all. My name is Nimi Kuryal. I am from Dehradun, Uttarakhand, and I am pursuing MSc in Agriculture Microbiology under Dr. Ajivir Singh. And my hobbies is drawing. Thank you.
Good afternoon, sir. Good afternoon, everyone. I am Ishita Mishra and I am basically from Varanasi, Uttar Pradesh. Currently, I am pursuing PhD from the Department of Agricultural Communication, College of Agriculture. And the topic of my research is agricultural waste management by farmers in eastern Uttar Pradesh. I am quite passionate about Indian classical music, and apart from that, I really love cooking, reading, and gardening. Thank you.
A very good afternoon to all of you. Myself, Dr. Anshural. I am professor in Department of Animal Nutrition, and mainly I am from Uttarakhand state itself. My complete education is from Pantnagar only, and my this MSc thesis work was related with nutritional evaluation of different rice varieties, and I developed a technique of estimating the digestibility of rice straw by hot water only. Usually we use chemicals by using neutral detergent solutions or acid detergent solutions. And my PhD thesis work was related with farming system. I studied the crop dairy production in 4 zones, that is in Udham Singh Nagar, Badaयूं, Muradabad and Ghaziabad district. And at present I am working mainly on the minerals supplementation in case of dairy animals and also in poultry. And mainly my recent work focuses on use of zinc coated urea in case of animals. And I'm also working on use of herbal feed additives in poultry. And at present I'm interested in submitting project on natural farming, and so I want to get divert to the natural resource management aspect, and that's why I just opted for this course, because at present there is problem of pollution, and until and unless we go for preservation of soil, water and air pollution removal, we cannot go for sustainable environment. Thank you. And my main hobbies are just reading and painting.
So myself, good afternoon, everyone. Myself, Tanushri, working as an assistant professor in JSA Science and Technology University, Mysuru. I'm pursuing my PhD on industrial wastewater treatment, so specifically with respect to textile wastewater. And my hobbies are cooking and reading.
Yeah, very good afternoon. Myself Shiv Prasad KS, working as an assistant professor from Department of Environmental Engineering, JSA Science and Technology University, Mysuru. And I recently submitted my PhD thesis. It was on electrochemical coagulation treatment for the removal of pollutants, that too from hospital wastewater. And today I'm here I'm happy to meet you all in this GIAN program. Thank you.
Good afternoon, everyone. Myself, Dr. Vishishta Nagraj. I'm an assistant professor in ISJC, JSS STU, Mysuru, and I have done my PhD in treatment of groundwater using physicochemical, biological, and what to say, physicochemical and biological treatment. So I am very happy to be here and meet you all. Thank you.
You didn't tell your hobby.
My hobbies are listening to music. That's
Good afternoon, sir. Good afternoon, all of you. My name is Manisha Rawat, and I did my civil engineering, my BTech in civil engineering from Graphicara Hill University, and my MTech in hydraulic engineering from GB Pant University. And I am a PhD scholar in UPS, pursuing my PhD in civil engineering, and my hobby is to travel.
Good afternoon to all. I am Dr. Shweta Rawat, Assistant Professor and Head, School of Biochemical Engineering, Bipin Tripathi Kumar Institute of Technology, Dwarahat. I have done my MTech in the heavy bio-oil remediation and the crude oil upgradation from the Indian Institute of Petroleum, Dehradun. That is the CSIR lab. And after that, I have done my PhD work in the integrated process development for the coal mine effluent treatment and microalgae low rank coal blended biofuel production. My research area is in the direction of advanced pyrolysis process, clean coal treatment processes, biohydrogen production, microbial fuel cell technologies. And my hobbies are writing and reading. Thank you all.
Good afternoon, everyone. I'm Roshni Baseda, pursuing PhD in Environmental Sciences under Dr. R.K. Srivastava, and my hobby is photography. Thank you.
Good afternoon, everyone. I am Astha Joshi. I belong to Almora, Uttarakhand. Currently, I am PhD scholar in Department of Environment Science, GBPT Pantnagar, and my research work is based on pine needle waste valorization. And my hobbies are dancing and reading, writing poems. And I am glad to be part of this workshop. Thank you.
I am Afia Tasnim. I am from Kolkata. I am currently pursuing my MSc in Environmental Science in Adamas University. My topic is finding any correlation between air pollution and vegetation with the bird diversity from pre-COVID to post-COVID duration. And my hobby is to writing and observing butterflies. Thank you.
Good afternoon, everyone. Myself, Anjali Tiwari. I am pursuing PhD in Environment Science under Dr. R.K. Srivastava. My research topic is Assessment of Life Cycle and Circular Economy by Sustainable Solid Waste Management Techniques. My hobbies are cooking, painting. Thank you.
A very good afternoon to one and all presented here. I am Nikita Joshi and I am from Uttarakhand. Currently, I am pursuing my Masters of Science in Environmental Science from College of Basic Sciences and Humanities, and my hobby is drawing.
Good afternoon, sir. Good afternoon to one and all present here. My name is Vijender Yadav. I am from Hisar, Haryana, and currently I am pursuing in my master's degree in Fisheries Science College. On my topic is on detection of heavy metal in Ghaggar River in Haryana. I am covering across 300 kilometers of the Ghaggar River and detection of from various points. And now I am here to learn the wastewater management, and my hobbies are like playing kabaddi, and I am also a state level champion in kabaddi. And instead of that, I am also district level champion in swimming. Thank you, sir.
Very good afternoon, everyone. My name is Udit Saxena and belongs from Bajpur, Uttarakhand, and currently I am pursuing my PhD in Irrigation and Drainage Engineering from Pant University of Agriculture and Technology. My current topic is related to groundwater management using GCM models and machine learning models. And my hobbies are playing badminton, driving, and photography. Thank you.
Good afternoon, everyone. I am Shubhi Kare. I am from Lucknow, Uttar Pradesh, and currently I am pursuing PhD in Soil and Water Conservation Engineering Department in GBPUIT under Dr. Deepak Kumar. And my hobbies are writing poetry and dancing. Thank you.
Good afternoon, sir, and good afternoon to everyone. My name is Anita. I am belonging to Ramnagar, Uttarakhand. I am currently working as a teaching personnel in the Department of Soil and Water Conservation Engineering, and my hobbies is dancing and cooking. Thank you.
Good afternoon to all of you. My name is Satyapriya. I am from Shahjahanpur, Uttar Pradesh, and my qualification are I did BTech in civil engineering. After that, I did MTech in environmental engineering from NIMT Ranchi, and currently I am pursuing PhD in environmental engineering from MNIT Allahabad. Thank you.
Respected sir, and very good afternoon to all. My name is Shivani. I am a master's student in chemistry from Bundelkhand University, Jhansi in UP. I am also a medical lab technologist from Government Medical College, Jhansi, and I want completed my PhD in abroad because my elder brother is doing PhD in Europe, Bratislava. Thank you. Sir, sorry, sir. In my Bundelkhand University. Sir, I want to complete it in Europe. I don't know.
Introduction. Shiva. Introduction.
Good afternoon. Myself Siyam Gotari. I am doing masters. Currently, I am in second year, and I am under the guidance of Dr. H.J. Shiva Prasad sir. And currently, my thesis topic is related to landslide susceptibility analysis through QGIS. Is it okay, sir?
Hobbies.
Enough?
Hobbies.
Hobbies? Okay. So, my hobby is singing, dancing. Come, Priyanshu.
Hello everyone, my name is Priyanshu Vora. I am pursuing my MTech from Pantnagar under the guidance of Professor Jyoti Prasad, and my thesis topic is oh, uh, dam break analysis in 2D modeling of across, and my hobbies are playing chess and carom. Thank you.
Good afternoon, everyone. I'm Ishita Srivastav, and I am from Chhattisgarh. And currently, I'm pursuing my master's in fisheries science from HEU Haryana. And my hobbies are I like to paint and to dance. Thank you.
Good afternoon, everyone. Myself, Shiva Tiwari. Currently, I am pursuing soil and water conservation engineering in Dr. Deepak Kumar sir. My research topic is chromium contamination in groundwater. Thank you so much. My hobby is playing badminton and reading novels.
So, very good afternoon. I think both long ka nind aa raha hoga after taking lot of good food in guest houses or even in our hostels. Yeah, my name is very big. I am making it short, but for the information of you people, yeah, my name is Halkurike Jayadevaya Shiva Prasad. Halkurike means it is the name of the village which I born, and Jay means Jayadevaya, it is my father's name, and Shiva Prasad is my name because my name, I was born on Shivaratri, Mahashivratri. That is Shiva's, what do you say, birth, if I am right. Okay, Shivaratri I was born, that's why my name is Shiva Prasad. My parents never thought some other name since it is an offering from Shiva, so Shiva Prasad they kept it. So finally, yeah, I am having many short names. Leave about H and J, Alkuriki and Jayadevaya. Shiva, particularly foreigners, they used to call me as Shiva, and locally or in general, Prasad. These are the two nicknames which I am. Yeah, coming to, I am basically Karnataka, from Karnataka, and I did my graduation long back from the only government engineering college at that time, Davanagere. Then I shifted on to south, completely to north. At that time, it was University of Roorkee. I did my MTech from there. So from the north, I think that time it was very difficult. There is only one train which used to move from southern part to northern part. That was a well-known Karnataka Express. It was, I think, if I remember, it was running from Kerala to Kashmir initially. Okay? Anyway, then later on, okay, south ho gaya, north ho gaya. I just move on to for my PhD towards east from Sambalpur University. That is University College of Engineering, Burla. I did my PhD, and after serving a few years in Karnataka, I shifted on to Maharashtra in financial capital of India, Mumbai. We were there for approximately 8 years or so, 8 to 10 years, and of course, short stint at a place called Kopargaon, where famous Shirdi Sai Baba exists. Just a short 2 years only were there. Then we had been to financial capital Mumbai. Then almost around 24 years back, I shifted to northern part of India, that is Uttarakhand. It is bordering Nepal, as you are aware. Okay. So my major working place is Uttarakhand. My hobbies are browsing. Then I am fully active in social sites, like I think someone was commenting here itself. That is almost all social sites, I should say. This is my just a brief introduction in respect of my hobbies. Yeah, my specialization is I am basically a civil engineer. Then I shifted on to hydrology. Hydrology is a transdisciplinary subject. You are aware, water. Hydro means water, water science. Then I shifted on to some resource management also from my PhD work. It's an then of course nowadays mainly I am water resources, hydrology and water resource field only. I am looking after international affairs of this university for entire university from the last 2.5 years or so in this organization. Thank you, please.
Good afternoon, everybody. So I am Deepak Kumar. I am assistant professor in the Department of Soil and Water Conservation Engineering, and presently I am the coordinator of this program. So as far as my biodata is concerned, I am MTech in Soil and Water Conservation from IIT Kharagpur. Then I have done PhD from IIT Delhi, and basically my research focus on groundwater contamination and its modeling. I have done postdoc from IIT Roorkee also, 1 year postdoc with Dr. N.K. Goyal. I think somebody has listened about his name, N.K. Goyal. I was also adjunct faculty in Western Sydney University. There I have worked on reuse and recycle of wastewater. Then for a few days I was also in France, because that was a collaboration between G.V. Pant University and few of the universities of the France. My hobbies are teaching and teaching to my students and to my son, and music also, classical music. Thank you very much.
Thank you very much, everyone. I think we have a broad horizon from different states, different background, right? And what I see is all are related one or other way to the environment. They have a different background. So that is what the environment is. I have worked in my career in different projects as a teacher, as a consultant in the government, right? In different places, different projects. India, Australia, Canada, and US. Different background people I have worked. So what I understand is, here we have a very good crowd. So I also see there are many faculties, scientists who are pursuing a very great studies in environment, water quality, groundwater, solid waste management, landfill. I also see biosolids. So you are working in the core category. Environment is like that. You need a variety of experts to make it successful. So that is why this course is designed, right? If you see, this course has a different components, right? So all different components are managed by different stakeholders, right? So all have to work together to make it successful. That is what I see. The very purpose of this course is to understand how this system works in other countries. It is easy to say why it is not working. So to understand why it is not working or why we are not at that level, I don't say we are not working. It is working in some place to this very slow speed. But other countries, they are very successful. That is the model I want to present, and you should understand how you can move forward, right? It is not in a comparison, it is to understand. Once you know the best system, then you can, promote with the modification to the current conditions. That is what you will have to do. You not only you have to develop your expertise, you are already contributing, is it? And you also spread this awareness to other people by students or wherever you are working, wherever you have an opportunity to work in different projects, make it work. That is what I all the time I say. You have education, aspiration, but will to contribute and create is very important. You should have a passion to do that. It is not just for the sake of doing something. So that is very important component. One has to develop and keep it forever. That is one. Second part is a hobby is always important. You have to also lead a happy life. You should also enjoy. Once you like, you should enjoy your work. Not only the failures. Failures are the first step for the success. That is what you learn. It cannot be everything successful. But the work towards successful is important. You may achieve some part and next person will carry on. That is how this is the environment. If you see how big it is not a one person. That is why I was trying to tell what are the different stakeholders in this industry. You see the industry people, you see the government, you see the activists, you also see the public participations. You have to work with the different expertise. You have to also borrow some of the expertise from other countries. So all have to work together to make it successful. Because the place where you are living right now, we have a limited space, source. Also all the resources are limited. The degradation. Every day we find a new product, new contaminant generates, right? So at the same time, we have a capability to generate the contaminants, but we should also find the solution, how to take care of that. There are certain things which we cannot live without that. But that is okay. At the same time, we should make sure that we should keep our environment, water, air and soil, perfect conditions. At least we should start working towards. So that is what about this course is. So you guys are doing great. I'm very happy to see you all, and your work and your background is just amazing and incredible. So thank you everyone. So this is all about that, and today what I'm going to do is I am going to do 2 tutorials. In the sense, I'm going to take 2 case studies. We saw in the lectures different components, how we work together. We will go tomorrow about the treatment side, of course. But today what I have done is I have taken two case studies, means two industries which discharge to the city wastewater. So two case studies just to highlight what was the problem, how it is identified, how it is addressed, what are the resources we spent on that, and how it became successful. So that is what I want to mention about the important steps. We have seen many revelations, this is contamination and all, it is there. But if there is an issue, there is a way to solve it. If you do that, that is what you have to go a step ahead to make a contribution and creation. Once industries are not like that. Industries, if you help them, work with them, many industries step forward. They also want a solution, but they are so busy, sometimes that may not be an intentional. If anybody wants to, one can step forward. I have done cases, success stories like that. Yeah, if they are willing to work, you can step one step forward to help them, give them some time, give them all the help they want, assistance from your side. Is it? Then it becomes successful. Then how you feel once the system is not there, and today you have developed the system. This is just unparalleled to anything. If that is the pride you are taking, if you step forward, you can make a change in the system. So that is what this case study about it. So in this, there is a food processing industry in a particular place in our eastern region. I have given some highlights, what it is, to understand. It is a food industry. It operates for the food processing. They do all kind of vegetables, clean it, and make it contaminant free, then pack and sell it to other countries all over the United States, right? So in the food industry, what happens? Large quantity of foodstuffs comes in. Then you have to, there are a system, the process plants which cleans that. Then there are solid generation, lot of solids is generated. In addition to that, what happens? BOD, concentration. So one particular industry was facing issues with the solids, because you have to remove the solids and then discharge. Otherwise what happens? It will create a problem to the receiving side. There are two components in the receiving side. Cities, what they do is, they build a wastewater treatment plant which basically treats domestic wastewater, correct? Then you have a certain industry, some part of the industry, few industry, it depends, you cannot put all the industrial wastewater into the domestic. Certain percent, it has a capability. You can mix certain industrial process water into that domestic wastewater, and that is taken care by the city, correct? You can do to some extent. But in certain places what happens? They have a large number of industries. They cannot accommodate, put everything in the domestic wastewater and treat. There is a capacity. That is why they do industrial wastewater treatment plants separately, where they can put a number of industrial wastewater is pre-treated and then it is treated by the industrial wastewater. That is how exactly you saw yesterday. That is a common effluent treatment plant, how it is called. Before that, when I was here in India, I have worked in the common effluent treatment plant also. or different. But it has its own issues, because if it is in a particular place, particular zone, it will be easier for you to track and collect them. But if they are scattered everywhere, it becomes difficult. You have to put more infrastructure, track that. That is what you have seen in the previous lecture, how it is identified, what are the issues, that you have already seen that. So this particular industry, the facility discharge maximum monthly flow of 9.5 MLD. I have converted that. It is 2 mgd. So this volume of wastewater is discharged every day. See, imagine the type of the plant. That is the usually tendency there. They have always a very big, whatever they do, a big plants. So that is easy to manage. That is just a system. That is why most of their stuff is mechanized, right? So 9.5 million liter per day, and maximum daily BOD load is this much, 57,720 kg. That will give you just an understanding the quantum of wastewater, the quality of wastewater, right? So that was discharged. Process water reuse facility, that is, they were discharging it to the city. They were having issues with the treatment. It was a dedicated facility, of course. I mentioned we authorize the city to take care of the wastewater which is coming into their treatment plants. So this is a little bit about history, when it was started, because what happens when they started earlier, treatment plants are not built accurately, right? Industry go on expanding. It is a problem with everywhere. But unless somebody given a proper attention, they will not upgrade. So that is why they wanted to expand and make sure that they will take care of the wastewater receiving. Okay. So if you see the system, what happens? They have a system. You can see from the left side, the big trucks will come unload there, then goes to the storage, clean up area, and this is the storage and cooking, pressing. That is the sources of wastewater coming from different processes, right? This is all the wastewater is collected from different processes. Then the dried product is taken out. Then the pre-treatment, what you will do? I said, when industry discharges to the receiving wastewater treatment plant, they have to pre-treat. So that is why you see, remove oil, recycler, skimming, it is taken out. Yesterday you saw a little bit of that. At one corner there was a skimming. It has to be removed before it is discharged there. Then settling, means it has a solids. When you clean that, it has a lot number of, the volume of solids. That is settling, then wastewater to the suspended solids here, the strain. Is it? Then this wastewater comes here to this pre-treatment unit, you see, then the different processes takes place, then the clean water, this goes to the treatment plant. If I show here, you will understand. Process water reclamation facility, this is the flow, solid removal facility, and winter storage and double liner pond. What happens is, treatment system is slightly different. Here it is the climatic condition. In the winter, they have to store the wastewater which is coming out of the system. Because in order to regulate, You cannot just discharge the wastewater as it comes, because you need a regular flow. When the receiving treatment plant always specifies how much wastewater we can accommodate. Is it? That is what I was telling you. They have a lot of limitation about the flow, about the different parameters what they discharge. So that is why they build a huge pond where the wastewater is first discharged there, then that is a buffer, right? Then they can regulate the flow. In the meanwhile, what happens? That also act as a settling tank. When you are collecting the wastewater, you are giving little bit treatment. If it is a pH is high, if pH is normal, no need to do that. You cannot, when you are discharging to the treatment plant, one thing you should make sure that you are not doubling the cost of the treatment. It is not necessary to treat here also, and you have to treat there also. No, you have to give that privilege to the industries also, right? You just cannot put everything there. If the receiving side is capable of treating, then why you want to treat it here? Treat at one place only, if it is not causing any harm, right? So that is your determination, how we will do that. So what happens? It is collected in the pond. When you are collecting the wastewater in the big pond, it must be double liner, geomembrane liners. They are in terms of 10 acres, 5 acres, such a big ponds, right? Double liners. I see some of you are already working in the landfill, leachate collection, I heard, right? If you are collecting the leachate from the landfill, what happens? It has to be double liner, geomembrane. If it is a single liner, what happens? The regulation says you have to have a groundwater monitoring. If there is a leakage, if it is entering the system, it may go to the groundwater. Then he said, no, it is a correct system. It is possible to do it one liner. No. If there is a leakage, how we will prove? Then you have to monitor the groundwaters. You have to always prove that our groundwater contamination is not going up. That is the system. Why? That is the rule. Then if you want to avoid a groundwater contamination or groundwater monitoring, groundwater monitoring is a big job. Some people have worked in the groundwater, right? It is a big job. You have to have a different monitoring wells around, and you have to take a sample. You have to make sure that it is not leaking anywhere. It is not causing contamination. That is a big job. So if it is a double liner, then they can avoid that groundwater system, right? You have a second layer protection. Then if any leakage is there in between, there is a system which shows there is a leakage, that the level goes up there. It is connected to a monitoring system. So the level goes up there, then they can understand there is a leakage. Then there is a way fix. So you have a double liner protection. Then you don't need a groundwater. That is why it says that the treated wastewater is put to a double liner system. Then the treated wastewater, how it is treated? All the suspended solids are removed. This is not that contaminated. If the BOD, biochemical oxygen demand, what you say, 5 days BOD we do, right? So if that BOD is about 300, 400 or maybe 800, then the receiving wastewater treatment plant can take care. Because what happens? Domestic wastewater, usually they are built for the domestic wastewater, where the BOD 5 is around 300, correct? If you have to give a little privilege for these industries, If it is 500, 600, 700 in case of food processing industries, then they say that you can discharge. Because when they mix it with the domestic wastewater, their treatment plant is manageable. So how it is helpful? It is helpful to the city also. These industries, you see, they are taking care of their treatment. They pay a lot of money to them. See, this is how the funding to the system. That is why it is always work for the cities and industries together. Right? So they get a lot of funding. Cities, how they will do, how it will build the treatment plant. It collects the money from the residents, and that money they build the infrastructure. But if the money funding is coming from the treatment plant or the industries, other resources, it is well and good for them. They can have a better system. If we have enough funding, regular funding, we can have a better system, right? So that is how the collaboration works there. So agreement will be there in that, even when they are discharging, this is the volume of wastewater we are taking. Then what is our job there? Regulator. If it is a delegated, city is delegated, then what happens? City will issue the authorization for them. Then the city will monitor them. How much is the volume they are sending? How they are taking care of solids? Are there any violations in the BOD? Are there any leakage? Is there any leakage? How you will stay? There is a leak detection test, which they will have to submit a report that it is not entering the groundwater, right? So that is how it is a win-win situation. Why I am giving this example is the industry and the city treatment plant work together. See how the financing is done, right? Here if we work in a two different direction, nothing will happen. They take care of them, and the city will run partially here and there. People won't pay tax. They won't be having the resource, right? So this is how kind of an industry and city collaboration. Instead of building one plant, you build a big plant, right? If it is a 5 MLD, you build 10 MLD. Big plants are easy to manage. You can have a lot of resources. You can also help industries. You will have a good collaboration. You can use the latest technology. This is how the system works, right? So this system has to be come to the existence here. That is what the very purpose of this. That is why I am giving example how it becomes successful, right? So when we say groundwater monitoring, what we observe, which is the major contaminant, is the TDS, the total dissolved solids. Dissolved solid is a very important component. That is why your groundwater, the characteristic of wastewater, groundwater changes. We have a different groundwater regulations also. Once the discharge is on the land, then the groundwater monitoring comes into picture. You have to be more careful. When you are discharging it to the river, fisheries, there were some people who were working on the fishery sites, right? So there are a lot of strict regulations also there. It is not only the Department of Environment, and also the fishery people will come into picture whether you are really taking care of the wastewater, because fishery standards are much higher, right? So that is how the collaboration works. The money is generated and the system works, right? And you are also helping the industry, right? And you are also you are making sure that they are not doing anything which is wrong. It is a win-win situation, and the government also monitors that. That means we monitor them. We also observe, we take the report, we see the sampling. They have to send every month the report, every month, and daily observation. See how tight it is. There is no chance of any movement here and there. Every day they will have to have measurements, weekly parameter measurements, and monthly or quarterly, maybe some contaminant if you observe, they have to monitor that, and yearly they have to submit a report. See, where is the chance there? So chances will reduce, the system will become more efficient. That is how it has to be managed. If you say that some industry is discharging, there is no regulation, but how long it is going to go, right? That is what I wanted to show. There is a system which can be worked out. So there should be some guidelines, regulations. That is what all people have to work together. That is the intent of this case study. If you see here, what is this pre-treatment system? I have put some line diagram. So this is the city, right? They have a treatment plant. There are many industries, 5-6 industries. What they will say? Okay, we will fund the city treatment plant, and they also take care of their residential wastewater. They can all discharge there. They can build a big treatment plant and they can take care of it. Both are happy, right? Government is also happy because they are doing it. And if there is any issue, then we interfere there. The city, what happens? See, if the city is capable of doing that, then we delegate. If they have to also step forward, if they have a funding, people who are working, there is a large team which works on that. It is not a one-person job. They have equally a big team which can do all the sampling, measurements, reporting, enforcement, all, and a lab analysis. Is it? So that is done here, city. If the city is not delegated, then we do directly, right? And if we delegate them, still we monitor. I oversee. There are reasons which I oversee entirely, and I also help the other areas how this delegation should be done. This is how. See, different industries, processing plant, discharge it to city wastewater treatment plant. It may be domestic, partially. There are certain situations, if there are 10-15 industries, then city says, okay, we will build another treatment plant. We will build specifically for your industry and we will manage, right? So they can build. I have an example. This particular place, they have both the city municipal wastewater treatment plant, that is the domestic wastewater treatment plant, and they also have industrial wastewater treatment plant. So what they do, there are 10 industries, we put 2 there and rest of them all we will be putting in this industrial wastewater. That is how they balance. They get a lot of funding also. There is a big team which monitors. I will sometime, there is a video also, I will show you how successful it became, right? So this is how, what you will do, when different industries are there discharging, you will build an equalization tank first, because some may be seasonally, they will do just 6 months in a year, right? And some will do continuously. Some will do few days in a month and few days off. So it is not consistent. To have a consistent flow, right? You cannot do that in the season you discharge a large sum of wastewater and in certain days you are not doing anything. See, it should be your treatment plant which is built has 2 important components. One is the hydraulic loading, another is the organic loading. You should balance both of them and then you discharge, right? So that is how, in order to achieve both of them, we do a big equalization. This is the small one. They are in 10-15 acres, multiple ponds, 3-4 ponds connected. I will show you some pictures. I think I may be having. So those ponds, they have a big buffer. They can draw the wastewater uniformly without affecting their main central system. This is all the receiving wastewater treatment plant is managed online. You can see how the wastewater is coming, what are the sampling points, what are the analysis. Daily it is a big job of monitoring all the stuff. And all the analysis data, the analysis has to be done by an accredited lab. When it is accredited, they have a responsibility. They just cannot do anything, right? They are monitored, and we decide where it has to be measured, when it has to be measured. This is all given in that authorization, which we call permit or an authorization, right? So it is all mentioned there. So these are the some conditions which put in the authorization, right? That is for the measurements. But in case of what happens, how if it is as good as storing a big, small dam, storage dam, then if it is too big, then the dam regulations are also there. If a embankment collapses, what measurements you have, what actions you have, what is the spill plan in your plant, what is the sludge, where your sludge goes, everything should be documented and it is open. Where if we have an authorization, then the person can go and monitor, see, ask for any information which is required. No one can deny, right? So that is how this is a win-win situation is created here, right? Then if you see the problems and actions, I've seen over the years plant, expands and excess building of solids. That was the problem, right? Then the primary source of solids in the effluent was due to inadequate volume of the base. They are called mud base, right? So if your treatment is inadequate, then what happens? There is a problem. This is the particular industry. There are number of industry. One industry I have taken as an example. This was having a problem with solids because their treatment system was small. Is it? Settling chamber was small. If it is small, then the flow, what happens? There is a less detention time. When the detention time is not sufficient, suspended particles won't settle. It will just go with the flow and it will cause a problem there, right? So that is why it is important to have a sufficient detention time. That is why the engineering evaluation is done. What should be the size, depth and all that is a common. A professional engineer will design and make sure that it is consistent and consolidated, all the information in that. So there is a screen, all the floating material, that is the normal treatment plant you have seen there, and we will also see more of this information in the biological treatment. So it has a rotary screen, existing base means that is the settling tanks, and it was discharged directly. This was the problem, right? Then we said, no, this is not going to work, because this problem will not be solved unless you spend money on the treatment unit. You should need big ponds where the proper settling is achieved and solids are removed and BOD is reduced. How you can reduce BOD? You can reduce by providing aerators, right? So this was the problem, and then took it this one. After the engineering evaluation, the efforts were made to stakeholders bring all the people at one place, right? What is the problem? Because you have to bring the receiving end and the discharging end, people around there and the regulator all together, and find out the solution. Then consultants will also be there. So then this is how the solid removal system is built, and the issue which was with the solid removal is solved. What is the outcome? They build a new treatment plants. Old treatment plant, they refurbished. They build a new treatment plant. Then they added the aerators also to reduce the BOD. That is the DAP system, dissolved air flotation. You have seen air flotation there, right? Rotaries were there in the wastewater treatment plant. Here also they put a DAP system. Once you put the DAP system, the oxygen content is increased, the BOD is reduced. That is how you will learn more about this in the biological system, right? So in this, the DAP system will reduce the BOD. I will show you the picture of that. So that is how the BOD and suspended solids issues are solved, right? See, then another important thing is there was a big pond there. You collect the water from the process plant, then if your system is not sufficient, that water will go somewhere. There was a stormwater pond. This wastewater was entering. You have seen in the morning some example. If your sewer system is just breaks like that, it will go enter everywhere. Even it may enter a lake around area. So that is how it happens. We made sure that no leakage from this industry goes to the pond. So pond is protected, correct? So what were the problems? The solid problems is solved because they built a new settling tanks, right? Increase proper detention and the engineering design was done on that. Then also you put a DAP system into place where you reduce the BOD also, and you made sure that this wastewater is not entering the big pond there, which is close by. So all the issues have been done. So if you see, rebuilt rotary screen and DAP system, then it went to the receiving wastewater treatment plant. You can see these are the new ponds built like that. See, this is the DAP system. This is the pond which was just filled with wastewater earlier, and now how it became very clean and neat. So these are the success stories. All the important issues related with the industry working together, these issues are solved. So this is how this system is done, right? This is about the first case study. If you have any question on this, go ahead. Right?
Any question?
You can also share if any other specific issue you have worked, there was a problem and there is solved, right? You can also share. There is no. So this is how the system works. If there is an issue, how you will solve? You have to solve step by step. Work, bring all the stakeholders together. Understand the issue around them. Give them a time. They also will step forward. Otherwise, what happens if you put for an industry, if it is producing large quantity of wastewater, if you put certain amount of fine, it's of no use, right? I have worked in the industry. Per day production was $2 million. If you put a $10,000, is nothing for them, right? So that is how. That is not your main aim. Main aim is to solve the issue forever. See, this problem is solved at all. This problem is solved forever, right? This is how there is an industry institute partnership, right? So this is how the system works. Okay, if you do not have any questions on this, that is fine. Thank you on this. Two minutes break. Okay. So we are at right time. We completed just 5 minutes or 4 minutes before 4. There is a 5 minutes break. We will see another case study, right? You can take a 5 minutes break if you don't have a question. Then I will go with the second tutorial. This is an interesting case study. What was happening is that lumber means it is a big wood industry. You know, in United States, lumber industry is a big one. Canada also. So they collect the lumber from the forest, then they cut into different sizes. They use it for construction purposes. Construction here and there is slightly different. They use a lot of wood. That's why you see beautiful houses there. Here also there are beautiful houses. So not like that. But large space, individual house, well planning. So they use lot of wood in the houses. This is one such industry which cut wood into different sizes, and they produce a lot of TDS, total dissolved solids, which is one step ahead of your suspended solids BOD. It is always seen in the groundwater. If TDS is high, your mathematics changes because it won't appear clearly whether TDS is there or not unless you measure it. Many of you know. So that kind of an industry. What happens if you don't pay attention properly? They will never expand unless something is there, issues you find out. These are the causes contributing to the land application or receiving wastewater treatment, and this is the problem. Then industry start thinking. Usually regulation and industry goes hand in hand, right? So this issue was, it was producing a high TDS and the industry was discharging it to city wastewater treatment. Loading wise, it was more than 30% of the loading hydraulically used to come from this industry, right? So what happens? You have a city wastewater treatment plant and industry with the high DDS contaminant water is discharged here. What was the TDS value? Much more, maybe 6,000 milligram per liter. We know because we measure, right? Here you may find much higher everywhere. It depends type of industry. So it was going on for a long time because when it is mixed with the residential wastewater, domestic wastewater, it has a very less TDS and there was a kind of a dilution. But I have told you already, dilution is not a solution, right? You cannot do that way. So what happens? City treated water is to go to the groundwater. What happens? City is to treat its wastewater, then they used to discharge it to the groundwater replenishment, right? This is one of the methods. I have told you earlier, treat the wastewater, then apply to the land for growing of crops. We have an example also, right? Then other ways, you treat the water, do a groundwater recharge, right? How you do rainwater harvesting and all. You can treat to a certain extent, then make it safe and then discharge it to the groundwater. Is it? If you don't want to use it for other purpose, why? There was no need for that, right? So that is a kind of a scenario. It is, that's why I have given this example where its the main product is the wood industry, log yard, spread in a large area of 53 acres approximately. That is little background. Established earlier right? So it was contributing major priority pollutant, one of the pollutant I would say, pollutant of concern is the TDS. So this was the kind of issue here. And it is little bit history about that plant. What was the success story when we treat that kind of wastewater? See, the groundwater criteria for TDS is 500 milligram per liter. In the groundwater, if you want to discharge it to the ground, you should not have more than 500 milligram per liter. That is the standard. Everybody has to follow. You cannot discharge high wastewater. But in today's scenario, lot of industry, especially computer industry, they use a lot of wastewater for air conditioning, because there is a big city where all the computer industry, big industry in the world are concentrated in one place. So ultimately they have a high TDS. That has to be taken care of. This was also kind of the scenario like that. This is a different place, small town, but small, discharging it to the municipal wastewater treatment plant. The major issue was TDS. If the treatment plant, receiving treatment plant, if it is designed for removing the suspended solids, BOD, nitrate and all, if there is no place for removing TDS, what will happen? It will just pass through, right? If the excess TDS pass through, and if you are putting in the groundwater contamination. But here, that was little compensated because it was mixed with the domestic water. But you cannot carry on that for a long time. Right? So that was the scenario. So we understood that this TDS is causing a problem, right? If you see here, this was the only one industry, because it was the small, not the medium kind of a town. So domestic wastewater coming from the residential area of the town, that to the city sewage treatment plant. And this is one of the industry. Loading wise, about 30 to 35%. It was contributing. That means that is big contributor. Loading wise, if an industry is contributing 30 to 35%, it is substantial, correct? So you cannot just go on doing like this forever. So I was there. So then the city treated water is discharged to the infiltration pond. You just leave that water, it will percolate, right? That is how groundwater discharges, recharging system. Rain is also one of them like that. During the precipitation, it enters the groundwater reservoir. That is how like that. So whatever the city treatment plant was just 1 MLD, right? 0.8 G to 1 MLD. Then the treated water was applied to the ground. Initially that was not there. This was the scenario. Then that was causing pass-through, which cannot be accepted, right? You cannot accept the pass-through or the interference. But here scenario was little dilution, it was going on. But we identified that is not the right thing. That also, it says that if is less than 20% of the loading, sometimes it is workable. But what happens, industries go on expanding, then it will go on increasing the loading conditions. What kind of a loading? Even though if your hydraulic loading is not increasing, but organic loading is increasing. And TDS is also one of the contaminants. And the consequences of TDS, you know, many people, what happens, right? Then increased TDS monitoring frequency. We wanted to know, we identified the problem. So how to trap that one? So then increase the number of monitoring. If you are monitoring once in a month, increase it to 15 days or 1 week and study that. What is the trend? How it is increasing, right? We did that. We asked the industry to do engineering evaluation, correct? We asked the industry to engineering evaluation. That is what I mentioned in the beginning. If there is a continuous violation, you can always ask for the engineering evaluation. You will say once, twice, you give opportunity. If it is not happening, then we will say your industry has to submit an engineering evaluation. Engineering evaluation, once you ask, then a professional engineer will work on that. They will find out what is the problem. And you have to believe that he is a professional, that is the different category there. So once you are in other countries, there are some certification, only they can do that, right? So they have a responsibility. That way you can understand. So engineering firms will involve, engineers will be involved, then they submit in a report. So yes, there is a substantial increase, right? So that was identified. Then they identified it was discharging about 40%, 45% of the loading. Initially, in 10 years back, the loading of the TDS was about 20%. When we asked the evaluation, that is why I told you, numbers are important. Without that, how we will make a determination, right? So initially it was 20%. There may be a number of reasons. Maybe the influent concentration also might have increased, not to that extent. But if the production increases, if you are adopting a method which is the old one, that may be a possible if it is not contributing major TDS. So that is also possible. So ask the engineering evaluation. Then what happened? No, 20% is not there, but it is contributing more than 40%. So you have a basis. See, there are big industries, right? You should have a solid ground to propose anything. It is just not like that you can say you have to do this unless you don't have a number. There are big industry, they can also, they have also a lot of good engineers. They can go to the court. There are industry. We also work with a big industry like Boeing. Do you know how many people work in the Boeing, which produces your 777, 777 Max, Boeings, big Boeings? About 35,000 people. Is it? Any country, if you want to place the aeroplane order, they have to wait for 3-4 years. So that kind of industries are there. So when you are dealing with them, you have to be also careful, and you should be sound in technically as well as legally, right? Here also there are legal people there also, but you should be. That is why I said your number, your analysis. There should be a lot of work is involved in establishing the solid grounds for that. So we did that. So what we noticed is there is a big contribution component for the TDS side. I'll go to the next flow diagram. I wanted to show it. Okay, let's come here. I will go back to the previous. So what was the earlier system? This was the earlier system. When we say that industry, you guys were not contributing 20, you are contributing 40. So what is the reason, you will have to find out, right? Then also they will suggest, oh, these are the reasons, that is why it is high. So then we will design in a different system where it reduces the TDS concentration. That is called ACA. So available technology is also important. Reverse osmosis is one of the technology where you remove TDS, high TDS stuff. So initial system was this one. They used to take a fresh water, existing system which has a softener and dealkalizer, right? Then condensate here, it comes to the boiler, blow downs, and it was discharged to the city. And these were the contributors, condensate and the steam losses. This was the process. That is why the TDS was high. Then said this was the reason, this is the old system, we will remove. See, that is what I said, when you work consistently with the understanding, you can reduce the contamination to a greater extent. You can provide a great solution, work together. That is what I said, contribution and creation. You can work just as it is. But if you go one step ahead and involved in that and make sure that system which is not existing, you will build a system. See, what they did is, yes, they agreed. Because 2 plus 2 is always 4, wherever it is, right? Anybody has to accept. So that was happened. They said, this is the old system which was contributing more TDS. Now we will take this off. We will put a reverse osmosis, right? What they did is, they proposed reverse osmosis treatment. So they always study 2-3 methods. This is more economical and efficient. Because the industry don't want to bother much about the little investment. Because their production is in billions dollars. So they just don't worry about that. So they hire good people and they built a system. They built a reverse osmosis system where the reject was only discharged to the city water treatment. See, this was the word, this was the proposed, then they put that system, right? So what happens? This was the system. Number of like that, we have shown only one, right? Okay, let's go back. This was the system, right? See, what was the outcome? The TDS, which was in terms of concentration about 6,000 milligrams per liter, was reduced to 500. See the magic. That means the 70% of the TDS loading for the city treatment plant was just gone like that. So this is the success story, right? So you work with them, established. Yeah, these are the success stories. So that is how the industry, regulation, consultants, all they will work together in order to make it successful. Otherwise, what happens? This will keep continuing. It was continued for many years. So I was also involved in this. So I was the one person who found this and moved it to the success. So that is why I wanted to show these success stories, how impact they will make. See, you reduce the pollution from, see, 70% loading, which was causing for many years. This is the creation, right? This is how these success stories are brought up into a system by working in collaboration. So that this is one of the example, important example I wanted to share with you. Then this is going on forever now. The problem which was existing for many years was just solved like that, right? Any questions on that? So these are the simple examples I am giving you. These are the industry which have an enormous effect. Their production is in terms of millions and billions. They are not small industry. So you make a lot of difference if by providing this kind of solution. How this is possible? That is what I said. there is a system, 3-layer system, which works federal, state, local, and the consultants, publics, all they work together in order to make it successful. This is how you can reveal a positive results if you work together, if you work mindfully, if you work hard to make it successful. They lead one step ahead, right? If you can do, just leave it, because it was going on for many years. But if you involve and want to really contribute, these are kind of the solution. That is why I wanted to pass on that to you. Should also just don't leave it. It is going on for many years. What will make a much difference? But there it is different, because there are a system. Even that system they want to work. But here there is a big job ahead of us. So that is why I want you to be aware and educate many people who are coming across with you. You have to also educate the next generation, contribute whatever best work you are doing, you can pass on to other people and to the system. Okay? So I think we are very close. I am on right time. So thank you for this. I want to show you one video.
Any question?
It is not the big one, which is related to our earlier example. We were talking about the removing of suspended solids, BOD, is it? That is the receiving treatment plants. So they expanded. I want to show you that video.
We can take 2 or 3 questions if.
Yeah. If we have a questions, I will
some
take.
queries.
Sir, actually, most of the times we go for the integrated type of the treatments, primary and secondary, all that. So, sir, this time you talk about the reverse osmosis. So, before reverse osmosis, there is some primary type of the treatment also in that industry, or
in that industry there was only the major pollution of that is a good question.
Yes.
There was a earlier, there is the only one issue was the removing oil and grease
Yes, sir.
trap, and then the TDS one.
Okay.
Because this is the industry where they were using river water directly in the wood industry. There was not much issue of the suspended solids.
Okay.
Right? So that is why the major our focus was on the TDS.
Okay.
Right? So that is why those treatments are not of that importance. So they already having their big tank, then oil and grease was removed, then this
Directly
the
for
water.
reverse osmosis.
Yes, TDS. Then it goes to the receiving treatment plant where they have a treatment there.
Okay.
Right.
Finally.
You don't want to do a double treatment.
Yes, sir.
You don't want to do a treatment here, there also.
Okay.
So if this plant is capable of handling that, you will give that privilege to the industry also. You have to give a privilege for the industry also. So they should also get benefited from this system. So that is how this was done. So, but the major TDS issue is much more than any other issue that people who you all know. So this causes a severe issues. So that was the intent of this case study, right?
Thank you, sir.
And I want to show is that is the place here where we worked on that. Just watch this video. By that it will be. If you have any questions, I will take.
I'm Heath Bateman, Public Works Division Manager for the City of Pasco. Previously, we learned about how your water gets to your home. But what happens once you're done with it? Well, that's a whole other unseen process. Let's dive into it. No pun intended. Wastewater takes a journey from your drains, is transported through sewer pipes and lift stations, ending up at the city's wastewater treatment facility. The first process screens out large solids, grit, and man-made objects. From there, treatment separates into a solids process and a liquids process. Solids are removed through clarifiers, then anaerobic digestion occurs before drying for disposal. The liquid wastewater continues to the biological treatment processes, the trickling filter, and aeration basins. Here, populations of microbiology consume the organics in the wastewater. After a final clarification process, treated water passes through ultraviolet light for final disinfection before being discharged back into the Columbia River. Like drinking water, the wastewater process is continuously tested to make sure it meets government wastewater regulations and is safe for discharge into the environment. We hope you've enjoyed your journey through the Pasco's unseen but always active water treatment process. For Pasco Pulse, I'm Heath Bateman.
One of the example I was giving it where the solids are removed and the BOD is reduced, then discharged to the city wastewater treatment plant. This is the receiving end of the city treatment plants. Like,
This video will describe the biological processes associated with aerobic digestion and their corresponding chemical reactions. Since aerobic digestion utilizes microorganisms to degrade organics, it is very important to understand these biological processes and their associated chemical reactions. If the chemical reactions are not fully understood, issues such as odors, alkalinity depletion, ammonia accumulation, high pH, low pH, and excessive total nitrogen going back to the head of the plant can occur. The first biological process in an aerobic digestion system is the biomass destruction. In biomass destruction, food supply is depleted, so microorganisms consume their own protoplasm to obtain energy for cell maintenance reactions. This reaction is described in the following chemical equation. The biomass requires 5 moles of oxygen in order to oxidize its own protoplasm. When the protoplasm is oxidized, it is reduced to carbon dioxide, water, and ammonium bicarbonate. This reaction describes how volatile solids reduction occurs in an aerobic digestion system. Essentially, under these conditions, the bugs will eat themselves, which means you need to haul less of them off. As shown in the biomass destruction reaction, ammonia is produced in the system. It is not only critical for ammonia to be reduced because it is very toxic to microorganisms, but it is also the cause of pungent odors. In order for ammonia to be reduced, nitrification, which is the second biological process, must occur. Nitrification is accomplished through nitrifying bacteria. In this step, nitrifying bacteria oxidizes ammonia with 2 additional moles of oxygen, reducing it to water, 2 moles of acidity represented by the hydrogen atom, and nitrates. Combining the biomass destruction with nitrification reaction, the biomass requires a total of 7 moles of oxygen for both processes to occur. The byproducts of the combined reactions are 5 moles of carbon dioxide, 3 moles of water, and 1 mole of nitric acid. Consequently, nitric acid is a very strong acid and can kill the biomass because microorganisms are very sensitive to pH conditions. In order to reduce nitric acid in the process, the denitrification process must occur. Denitrification is the final biological process in a controlled aerobic digestion process. Denitrification is accomplished in the absence of oxygen. This forces the biomass to oxidize 4 moles of nitrates, which is reduced to ammonia bicarbonate, which is a form of alkalinity, and 2 moles of nitrogen gas. Combining the biomass destruction and nitrification with the denitrification step results in the biomass oxidizing only 5.75 moles of oxygen and reducing it to 5 moles of carbon dioxide, 3 moles of water, and half a mole of nitrogen gas. It is very critical in the denitrification process to create an environment without oxygen, because microorganisms will prefer to oxidize oxygen instead of nitrates. Without this step, nitric acid will continue to accumulate and consequently deplete the alkalinity, making the environment inhospitable for the biomass. Alkalinity recovery due to the denitrification step is important because it can neutralize the nitric acid created in the nitrification process. Aerobic digestion is a critical piece of many treatment plant solids handling solutions. Optimizing and operating this process can not only save operators a lot of headaches, but can also reduce cost and improve the environment. For more information, please contact your local Ovivo sales representative or visit.
What you observed is, in the first system, they have just highlighted how the city wastewater treatment is collected and treated. In the second system, I have given little brief mathematical analysis how we treat the nitrate, how the biological treatment takes place. Tomorrow we will see more about this, how the biological system, advanced biological systems, what are the different component of biological system, how the wastewater is treated, and also why the biological systems are more dominant in today's world also. Is it? So all that will be put into my lecture number 4 and 5. Right? Okay. Thank you.
Thank you, sir. Thank you for total lecture.